Dear participants of the webinar, Boreal Forests and Climate Change. We are now into day 2, mainly organized by the Royal Swedish Academy of Sciences, where I'm currently Vice President. And the moderators today will be also members of the Academy, Anders Wijkman and Anders Lindroth. But first, let us hear something about highlights of yesterday, summarized by Erik Pihl, who is Science Officer of Future Earth. So please, Erik, tell us.
Yeah, thank you so much, Lars, and thanks everyone for a great day yesterday. I want to hand out another thank you to all the speakers, and particularly the moderators who were able to keep the sessions well together yesterday. And I'm looking forward to another great day today. So you see, I'm here in the Boreal forest. I thought it was a good occasion to get out and take the meeting from here. There are several, I think, important takeaways from yesterday that I want to bring into today's meeting and kind of frame the discussion. So one thing we learned is that how important the boreal forests are in for the current carbon cycles. It's been a very trusted and a large sink for carbon dioxide. Together with the temperate forest, it takes up 1 to 2 billion tons of carbon each year, and then you have to multiply that by almost 4 to get how much carbon dioxide that is. So it's been extremely important in countering the effects of humans of letting out carbon dioxide. But we also learned that we cannot take this for granted. There may be changes in how the boreal forests act as a sink as we go into the future. We had a long discussion about wildfires, for instance, and there are lots of uncertainties here. So many of the disturbances and the effects which are cascading and interplay, drought, insects, wildfires, they all connect together and can influence how well the forests act as a carbon sink and for all other reasons, other purposes in the future. So therefore, it's a bit uncertain exactly what will happen, and this is not covered yet in the current models that we have for climate change. This also means that we need to be very cautious about things like overshooting 2 degrees, as that would mean more than 4 degrees of warming here in the boreal forests, which could lead to some different kind of tipping points or cascade effects. And we're very uncertain about when that, or if that happens, and how that would look like regionally. We also learned that the boreal forests are mainly managed forests under different types of management regimes. And that means that what we can do, and they also to a large degree not being actively deforested, at least not by the definitions that are being used. So the actions we tend to talk about when we discuss what we can do about forests and increasing the land sink are different than it is for tropical forests. So things like reducing deforestation or reforesting degraded lands are not as much an option in the boreal forest. It's much more about how do we manage the forest we have. And I think that is one of the things we'll be going into the conversation today. How do we manage the forests we have? This is particularly true, I think, for Sweden. We had a discussion about the old growth or the unmanaged forests. And there was one of the presenters talking about that we need to understand these better, to have a baseline to understand what is the effect of managing forests. If we don't know exactly how the old growth forests or the national forests behave and what they would have done in the current regime of increasing CO2, we don't really know what the climate effect is of management. And we might have underestimated how much CO2 that an old growth forest can take up with these conditions where we have increasing CO2. But there was discussion there, and also many saying that old growth forests do tend to go towards something closer to a neutrality when it comes to CO2, or at least taking up carbon much slower than younger forests that are in an active growth phase. And I think we'll be hearing more about that today. But there was an alarming figure that we're losing the old growth forests at a rate about 1% per year in Sweden, which is alarming, particularly because of the high natural values we have in these forests. We also heard that, as kind of a starting point, I think, for the conversation today, that when it comes to substitution, it's not natural to say that, at least in the European perspective, that we're always substituting, like that we have a climate effect from substituting fossil fuels or concrete or so with bioenergy, because many of these industrial products and energy products are already covered in the current emission trading schemes. So they need to be reduced in any case. So that we substitute this with biomass does not necessarily lead, or perhaps per definition does not lead to reduced emissions, but it may allow us to do more, to have more economic activity. And then finally, and I think this is one of the most important points that came up yesterday, that we need to have a multidimensional perspective of the forests. They're not just carbon sinks, and perhaps we shouldn't be thinking of forests as much as carbon sinks as the other values that they have, the economic values, the recreational values, the natural values. And I hope to hear more about that today. So looking forward to a great day. And yeah, handing over back to you, Lars.
Thank you very much, Erik. So I'm Lars Bergström. I'm the president of the Academy of Sciences in Stockholm. And now it is my task to introduce really the moderator of the first session today, which is what are the future expectations on forest materials and energy, and what are the potentials given ecological constraints? And the moderator there will be a well-known person in Sweden in this field, Anders Wijkman, who has written books about climate change and planetary limits, and has been very active in current debate on CO2 emissions. And he is also the Swedish delegate in the environmental panel of ESAC, the European Academy Science Advisory Council. So please, Anders, lead the session number 5.
Thank you very much, Lars, and good morning to everyone. And like Erik, Pihl said, we had a most fascinating meeting yesterday, and we were guided by outstanding expertise. And I'm confident that we will have as interesting discussions today. As Lars indicated, we will zoom in more on Sweden, not only Sweden, but we will talk a lot about the Swedish situation. We will look at demand for forest materials, the possibilities or opportunities for substitution, but we will also after lunch talk about forest practices. And the first session contains 3 speakers. We are privileged to have Ebba Willerström-Ehrning from Fossil Free Sweden, which for those who live in Sweden know is a very important government project stimulating different sectors to look at transformation to a low carbon society. And Fossil Free Sweden has drawn some conclusions about substitution, and in particular with regard to demand on forest materials. So Ebba will lead us off. After that, we will have an intervention or lecture by Thomas Lundmark, who is professor at the SLU in Umeå, and who has been a very active discussant or debater on these issues for many years, and recently wrote a paper looking at demand for forest materials and concluding that there seems to be a shortage if we look ahead. And finally, we will have Sten Nielsen, also professor. He has been the Deputy Director General of IASA for many years. He has been advisor to many governments. I would describe him as a very senior personality in this field. And he is currently, as I view him, trying to build bridges between, on the one hand, the forest industry and environmental interests. A much needed bridge building, I would say. Like yesterday, questions will be at the end of the session when we have heard the 3 lectures. So please, Ebba, the floor is yours.
Thank you. I'm just going to see if I can share my screen here with you. Yes. Yeah, good morning, and thank you for letting me speak with you here today. I'm Ebba Willerström-Ehrning, as Anders presented me as, and I'm a project leader here in Fossil Free Sweden. And I'm currently coordinating our work with developing a biostrategy. And I was thinking that I will start to talk a little bit about Fossil Free Sweden, because maybe not everyone knows about us. And then I will continue with talking more about the work we're doing right now with our biostrategy. Fossil Free Sweden's main purpose is to increase the pace of the climate transition, and we were started by the government ahead of COP21 in Paris in 2015. And as I think Anders also mentioned, Sant Axelsson was shortly after that appointed to be national coordinator for Fossil Free Sweden. And we gather today around 500 actors that puts themselves behind the goal that of making Sweden one of the first fossil-free welfare nations in the world. And the actors contain of businesses, municipalities, regions, and organizations. And what we do is that we challenge all our actors to take measures to reduce their climate emissions. And by doing this, we think that by being a forerunner, they can inspire others to follow and lower the thresholds for them to also do the same and do this, to take these measures to reduce their emissions. And by working with all these different actors from different kind of areas, we think that we identify obstacles and opportunities in order to accelerate the development that is needed to transform the society into fossil freeness. And we also produce political proposals to do this. And what we do is that we gather a width of actors behind these proposals. So that makes it easier for the government then to take action on these proposals when they see that there's a lot of actors that stand behind them. And in Fossil Free Sweden, we have 22 different industry sectors that has produced their own roadmaps for fossil-free competitiveness. And in these roadmaps, they show the opportunities that is with the transition, and they identify the obstacles that they have. And it also contains proposals for solutions, both through their own commitments, but also political proposals. And to do this, it's a way to show what a fossil-free business sector can look like and what issues is needed to be handled to make this a reality. And also it's a way to show that this will create export opportunities and new jobs. And all roadmaps, they have goals to become climate neutral or fossil-free by 2045 at the latest. But as you can see in this picture here, a lot of them have put their goals a little bit earlier than 2045. So there's ambition here in this group. The roadmaps cover over 70% of the emissions in Sweden. So by implementing them and help the industries to achieve the goals to become climate neutral, we think that we can have a big impact on how well we can manage to lower our climate emissions in Sweden. And that is why we in Fossil Free Sweden now has full focus on doing exactly this, that is implementing the roadmaps. And one of our methods to do this, it is to develop these strategies. And these strategies, they handle conflicts that can appear between different roadmaps, but also they take a wider perspective. So that then they can do by implementing the roadmaps one by one. So there's a wider perspective in these. And they contain proposals of measures we think is needed in these respective areas. And so far we have presented 2 strategies to the government. The first one was the strategy for a sustainable battery value chain. And the second one was the hydrogen strategy that we presented to the government in the beginning of this year. And now we're currently working on a bio strategy and also a finance strategy that we will present during this year, 2021. And some things about the bio strategy. So we're not done yet. So this is like primarily the results, but our starting point here is that we want to put together the demand for biomass that exists in different roadmaps. So, but to get the full picture, we need to complete the roadmaps with the analysis made by Swedish Co2 and EVA, because the roadmaps doesn't quantify the demand for biomass that we needed. And also there is, for example, chemistry industry doesn't have their own roadmap. So we needed to take in some other background sources as well. And then in this chart here, you can see this is only the demands on by and residual products. So it's not sawnwood products, pulp or paper. So it's just by and residual products that you can see here, the demand for those. And as you can see in this picture, we have highest demands increased in demands 2030, and that is in the transport sector. And that is mainly due to that we have a very ambitious climate goal in Sweden, where we're supposed to lower our emissions from the transport sector by 70% until 2030. So there will be a high demand for biofuels in the transport sector until 2030. So, but there is also some demands from the industries such as steel industry and minery, for example. And worth to note here is that the electricity and heating sector is the same. The current use is the same as the maximum demand here for biomass 2030. So they don't assess that they will have an increase in biomass until 2030. And in the strategy, we will also assess the potential for an increase in biomass outtake. And we do this based on Paul Bergström's research. But what we do is that we take the assumption that the felling from the forestry will remain at the same levels as today, and also that the agricultural land will remain at the same levels as today. And we are aware, of course, that this not all agree with us with this, but we think that we feel that it's difficult to predict what will happen. And therefore, we have chosen to take this more defensive approach. And I think that this will also help us when we present this strategy to the government, because the end result, we will try to match the demand with the potential to see how it can match. And if we have this defensive approach, we show that this is possible, even if we have this defensive approach. But as you can see here, the potential demand for biomass 2030 does not match with the biomass potential for 2030, and the demand exceeds the potential with around 40 terawatt hours for 2030. And if we move forward and talk about what will happen, and well, not what will happen, but the potential demand for biomass until 2045, you can see that the demand has increased even more. And this is mainly due to the chemical industry that will need a large amount of biomass to replace fossil raw materials in their products. But also there's further demands from the transport sector. For example, aviation has increased demand in 2045. Still, the electricity and heating sector does not increase their demand from today, but they, as you can see, they have a quite high demand as they are today, the current use. So it's a big part of the bar there. And the increase of potential of outtake of biomass is 50 terawatt hours in 2045, but still the demand exceeds the potential by approximately 60 terawatt hours in 2045 if we should believe this potential demand for biomass. And of course, we've made the same assumptions about the potential 2045 as we did for 2030. So as I said before, this is our starting point for our work with the biostrategy. So now we are in the process of illustrating the potential of alternatives to biomass in different sectors to prioritize biomass where there are no other alternatives to replace fossil material with biofuels. So yeah, we're trying to find these alternatives really then. And I mean, the most obvious example of that is electrification that goes faster and faster than ever. And that will, I mean, of course, affect the demand that the transport sector have, but also the demand that is in the industries. And we also have looking at new potential for techniques in the heating sector, such as sun heating perhaps, or geothermal heating, and also more use of residual heating that can decrease the demand for biomass some. And also we have chemical recycling of plastics that has probably good potential to affect the chemistry industry's demand for biomass to 2045. So our aim is to produce a basis for strategic choices about where bioresources can be used in the most efficient way in the transition to a fossil-free society. And in this, we are identifying obstacles, challenges, and solutions for this to become a reality. And in the strategy, we want to show how to optimize the value of bio and residual products from forestry and agriculture and achieve a more efficient use of bioresources. And how we do this is that we develop the strategies in dialogue with the industry, research and organizations. And these actors that we have this dialogue with, we hope that they support the strategy when we hand it over to the government. And the biostrategy we will hand over to the government just before midsummer. So we have approximately 1 month left to do the remaining work. So yeah, we're at hard work right now. And I think I will stop there. So thank you for me for now.
Thank you, Ebba. Very interesting presentation. And we can understand that you have very busy times because you have to finalize the strategy within a month. And there seems to be tremendous challenges. I have a few questions already in my head. One is how to optimize the use. If there is less supply than demand, do you use market mechanisms or do you use policy instruments or a combination? But we can come back to that. So thanks you again. I should like to remind the audience that please use the question and answer function on your computers and put questions. They will then be transferred into the chat so I can look at them, but you cannot use the chat function. Please use the Q&A function. I hope that is clear. And we welcome, of course, questions. Now, Ebba, thank you again. Now, Thomas Lundmark. You have done similar studies, I know, so please share with us your wisdom and experience.
Okay, thank you. I will start sharing my screen here. Hello, everyone. It's a pleasure to be here, having this very interesting discussion. I hope you see my presentation now. I will try to give you some perspectives of the Swedish forests in a past and present and future dimension in a way then. So I will start with the past Sweden, just to remind us that there has been a long history of forest use in our country. During the 19th century, there was a strong era of liberalization and everything was possible. And it was during this time that the forest industry merged in Sweden, and we had a very, very strong financial economical development in the forest sector. And in fact, I think in the beginning of the 20th century, more than 60% of the incomes to Sweden had its origin from the forest sector. So it was really, really an important component in the development of the future Sweden. And for these reasons, you can say the politicians started to worry about the future. What will happen if we do not start to manage our forests in a very sustainable way? So because it's so financially important, we want to safeguard this resource for the future. So we actually got the first Forest Act in the early 20th century, starting to secure and safeguard forest regeneration after harvesting. And in 1923, we made the first national forest inventory at a large scale. And already then we defined what is productive forest and unproductive forest. So we considered the forest, the productive forest, as a cropping system. I think this is important to realize that already 1923, we saw the forest as a cropping system that should be managed in a sustainable way for the future. We developed or we tested several silviculture systems, everything from kind of continuous cover forestry systems to even age management systems. And in the 1950s, there was a shift towards rotation forestry with even-aged stands and an even age class distribution in the country. That was the long-term aim. This means that the forest that we have today is a result of a very long tradition of forest policy measures and market interventions. And I used to say that it's at least 2 generations of forest managers and their ideas about what is the best practice that has formed the forest as we see it today. It has been very actively managed for more than 100 years. And this has been a continuous process where we have always seen change. I'll see what, and then that has formed the landscape in a way that what we see today is a forest landscape that is a mosaic of different stands with different species mixtures, and we have a relatively even age class distribution in the country where we combine tree harvest with other considerations like biodiversity and other social values. So it's in fact, it's really a kind of multiple use, since we also have the every man's right to pick berries and recreate in the forest in our country. The forest it's owned by some 320,000 private forest landowners, relatively small holdings. They own approximately 50% of the forest area in Sweden, and the other half is owned by a handful of larger forest companies. And I would like to stress that each and every property has a forestry plan. This is what you can see to the left here. Where the property is divided into management units or stands that are well described and have a management plan for the future. So all productive forest land in Sweden has a plan for the future. And this planning has resulted in a country, or this planning has resulted in forestry that has been able to maintain a high level of harvesting at the same time as we have preserved the carbon sink in the landscape. This figure is from a manuscript that has just been recently submitted, and it contains data actually from 3 countries. It's from Sweden and Norway and Finland. They are very similar, these countries. And what you can see here is the development from 1960 and how the forest carbon has been developed. And you can see that there has been an increase in harvested wood over this period, while we at the same time has been able to maintain the carbon sink in the soil and living tree biomass. And this it can be explained by the fact that management has also resulted in increased growth of the forests. So we have more forest growth at the end of the period than in the beginning of the period. And this explains why we can maintain both the sink and increase the harvest. If we then go back to Sweden and put all these three time perspectives at the same figure, then you have annual stocks or growth at the y-axis in million cubic meters, or forest cubic meters, as we say in Sweden. And then you have a dotted line in the center of the figure. To the left, it's measured field data from the National Forest Inventory. And to the right, then it's a modeled future where we assume a business as usual approach when it comes to forest management. And we have used the Eureka framework that is commonly used in Sweden. And there are a number of colors here. And you can see then that the dark brown, that is the annual harvest in Sweden. The lighter brown color is the mortality that always occurs. And it's on the land that is available for wood production. And then there is a light green color, which is then the stock change, the increase in standing biomass at the land that is available for wood supply. Then you have a darker green and a darker brown, and that is then the stock change at the set-asides and the mortality at the set-asides. And I would like to explain a few things that has happened over the years. And if we go back to the early 1960s and the 70s, then you can see that the gap between growth and harvest was closing relatively dramatically, in fact. And this was a time when the forest industry, the demand for forest-based product was increasing a lot, but the growth of the forests were not increasing at the same speed. So during this time, the forest policy and the forest industry measures were to increase growth significantly to meet the future increased expected demands. What happened in the 1970s, most of you know that then came the oil crisis and a very strong change of infrastructure in the heavy industry in Sweden and in Europe. So there was a restructuring of the forest industry, lowering the demand instead of increasing demand. And this created a situation from 1980 and onwards where we had a very big surplus of growing timber on the land that was available for wood production. And during this time, we also started to discuss other values in the forest. And it was not such a dramatic thing, I think, because there was not a big trade-off then. There were room for nature conservation measures. And this resulted in the situation that we have now, that you can see that there has been an increasing area of dark green, which is then the growth on set-asides. And if you look carefully on the annual gross growth on land available for wood supply, you can see that from 1990 and onwards, it hasn't been increasing very much because the increased growth per area has been balanced by increased areas for set-asides. So this has closed the gap between what is harvested and what is growing on the land that is available for wood supply. So you can see that the light green color is more or less disappearing over time. There are some worrying signs when you look at data like this. First of all, if you look at the details, we can see that on the set-asides, which is more than 10% of the productive forest area in Sweden today, the mortality is expected to increase, and the growth is also decreasing. We have heard several speakers talking about that yesterday. And this means that we got a weaker carbon sink on the set-asides. And that is actually today the dominating carbon sink in the Swedish forest landscape. So that is worrying. And at the land that is available for wood supply, we see a slight growth increase, but also we expect this to be followed by a slight increase in harvest levels. So the total effect of that is a very similar or a slightly weaker carbon sink. So in total, the carbon sink strength looks like it's going to get weaker if we maintain forest or do forest management as today in the future. And then we heard from Ebba Willerström-Ehrning that there are quite significant political ambitions to turn Sweden into a fossil-free country. And when I have made estimates on that, then it really depends on a lot of assumptions. But then we get demand figures that range from something that needs 30 to 70% higher harvest levels than what can be sustainably maintained in the country. So that is really, that is something to work with, you can say. So what we are facing, that's actually quite a number of difficult decisions. We definitely seem to need more forest-based products in the future for consumption. And at the same time, as other speakers also have mentioned, we need to maintain the carbon sink in the landscape. It should be preserved, or if possible, it should be increased actually to support the climate policy. The solution has previously been to increase forest growth, but there is a significant debate, at least in Sweden, but I think in many countries in Europe, whether we should intensify management or not. So that, I think that is also a part of the reason for why we have this seminar, that there is a big discussion about should we conserve our forest for other values than wood production, or should we intensify management to increase the supply of renewables for societal consumptions. So the challenge is quite significant. And what we see now in Sweden is that the Swedish foresters, they are working, they're struggling with developing forest management and to develop, we can say, management strategies to meet the future expectations. The carbon sink should, if possible, be increased. So it has to be considered much more than it has been done before. We have to invest in new forests that create opportunities to harvest more in the future if we're going to meet increasing demands of forest-based products. And in some way, this results in even more active forestry than what we see today. We have to focus on growth and yield. We have to really limit mortality. If you remember from the slide before, the mortality is actually increasing. We have to focus on carbon sink, that should be at least maintained. We have to be more active when it comes to biodiversity considerations. And to summarize, it ends up with the title of a former seminar that we had in Sweden this year. We need more of everything. And then the question is whether this can be done or not. And I think that a very, very important question to answer is whether it will be socially accepted that we see the forest as a cropping system. I mean, it's for the landowners, and especially for the landowners, it's very natural to view the forest as a cropping system where you have a management goal and you invest in management for coming generations. But it's not necessarily perceived like that in the society as a whole. We know for sure that it can be done because we have empirical evidence. From 1960 until now, we have been able to increase the harvest levels by 50% and maintain the carbon sink because we have increased the growth by also approximately 50%. So we know that it can be done. But the question is if we really want to do this in the future. If it's going to be possible, then we have to accept the fact that forestry is an extremely long-term business. You have to have a perspective that accepts the fact that what we do today will be that will decide what options the coming generations will have to use their forests. And it fits well, I think, with the old Brundtland statement, where they say that we should use the forests to meet the needs of today, but we shouldn't do it in a way that compromise the ability of future generations to support and meet their needs. So if we then try to view the Boreal biome as such, how can should this be managed? I think this is the answer is it depends, because we have to well, at least discuss what do we think about the consumption needs for the future. How will consumption develop? Because that is really setting the kind of a framework for forest management. And in that context, what will the role of the forest play to meet the demands of the future? It's not so often that we see that this is agreed upon when you discuss whether you should preserve more forests or you should manage them more intensively. That what assumptions have the different the different people that are discussing this, what have they made in relation to consumption needs? And an extremely important question is whether how we are going to use the fossil resources in the future. Should the coal stay in the hole, as people used to say, or the oil stay in the soil? I mean, if this is really, really important, then we have to find other sources for our consumption than the fossil-based resources. And another issue that is important to discuss is whether we can accept the fact that we manage biodiversity. Can we help nature to be rich in biodiversity by active management? If that is considered to be acceptable or not is important for what we can gain. And then, since my profession is in silviculture and the professor of silviculture, I always tell the students that we have to know what forests we have, and we have to define where we want to go. What future do we want with our forests? And if we can do this, then forest management as such is a really powerful tool to get us to these goals. If we then also remember that we have forest owners that are doing management as a business, and if we give them the right incentives, I think that we can actually get to where we want to go in the future. And an other important thing is that whatever decisions to be made, they should be supported by sound science and proven experience. This is an important base for the decisions about how to manage the forest for the future. And my final slide is just reminding us that we have a very strong tool in silviculture. With active silviculture, we can actually turn a forest landscape into almost anything. So I will stop there and thank you for your attention.
Thank you, Thomas, for this interesting historical perspective and looking into the future. I can tell you that I have something between 15 and 20 questions already posed. The question and answer session or part of this session will be interesting. Thanks you again. And now, Sten, the floor is yours.
Thank you very much, and good morning to everybody. I will speak about economy, markets, and industry, the forest industry. But before I'm doing that, I will make a short summary where I'm standing in the current debate about with forest carbon, And it is also what I think might take homes from yesterday, and there's a very good fit between those. So next, please. So we have simplified two camps in the debate today. One is about or arguing don't harvest, and the other camp is saying maximize the harvest. And both of them are maximizing the climate utility as the system perspective. But that is not the correct concept, because we must have a holistic view, because there are so many co-benefits of the forest. And the objective of the forest must be to have a strong sustainability for the society. I'm also of the opinion, based on yesterday's discussion, that forestry will not solve the society's transformation problems for a sustainable climate. I also doubt that we can reach the Paris Agreement without substantial change of consumption of the economy and reduced use of some of our natural resources. Next one. The uncertainties about the carbon balance of the forest sector are huge. And I have spent a number of years writing books with other people about that. And the uncertainties are up to plus minus 100%. And a good friend, Stefan Körner in Switzerland, who is working with computerized experiments in Switzerland, he is saying the strongest driving forces for the forest carbon cycling are the nutrient conditions and the moisture conditions. And we don't have that into the models we are working with today. And there are other people, including Anders Lindroth, having demonstrated that the models used are too simple. So my strong view is that the carbon analysis without assessment of uncertainty and robustness of the models are not very helpful. We can also see that in the analysis carried out, there are different systems perspective, and we have to define what kind of systems perspective we are working with when we are doing the analysis. I also miss the economic aspects in those analyses. Next, please. One of the key arguments for using the forest for the carbon is the effect of substitutions by harvested wood products. The uncertainties are very uncertain, and Marco was already bringing up that yesterday. And just to illustrate that products regarded as long-lived may not be that long-lived. So the long-lived products is about 20% of the volume we are using in the industry. That means the lumber. But 20% of that softwood lumber produced in Europe is used in pallets. And they have a lifetime less than 3 years. So they are not that very long. Next, please. Thomas made a good statement a couple of weeks ago, and he said we cannot speak of a future without talking about consumers and markets. And that is completely right, and but we have to do it in the right manner. Next one. We have a changing consumer behavior. There are a number of studies, there are quite a few, I would say, demonstrating that there is a strong preference for buying sustainable forest industrial products. And it's increasing rapidly, and it's changing most rapidly in the younger generations. And it's happening both in developed and in emerging economies. So it's not just in developed economies. There is a pressure on bringing in climate and biodiversity aspects in the current certifications. And if you are not meeting those demands, we will not have any markets. So we have to adjust to that. Next one, please. Yeah, Thomas was speaking about the goal conflicts, and that is correct. So I have put in two demand figures, or curves, or lines. And if you look at the lower one, we can call that the current timber demand. And we have a supply, or two supply functions, and the lower supply function is the current timber supply. And that is giving us a volume and a price according to the red line. And as we heard from Ebba, there is a demand on increasing bioenergy. And that means that we have to push up the demand. And by that, we are also increasing the prices to the, and that will be the yellow line. At the same time, we have something called the environmental goal in the Swedish legislation, and the one concerning forest is called living forest. And if you are going to achieve that, we have to push down the supply of wood. And that means that, again, the prices will increase and the harvested volumes will decrease. And whatever we are doing, we have to fill around with this figure. So the current EU climate law will affect it in the way that we are pushing the environmental supply up. We are, by that, decreasing the harvest potentials. We can have another example, and that is if we have a carbon price for growing carbon, we'll move in the same direction. Next one. So the major conflict is between growing forest or harvesting forest to meet the industrial demand, and the other one is to keep the forest for carbon sequestration. So let's look at the demand side. We are seeing a growing population and a growing world GDP. And over time, the GDP per capita has defined the demand of forest industrial products. And it has given a steady increase of demand. And what we see now in the developed economies is that we have reached a saturation point and it is going down. The next one. But we have to go beyond the GDP capita to understand the market. The GDP is including a lot of strange things, and that not long ago, for example, the prostitution in the UK made a major contribution to the UK GDP, and that has nothing to do with the consumption of paper. We can see that the private consumption is a much better factor for understanding the consumption of paper and board. And what we can see here is that it is decreasing over time. So we have the same situation with paper and paperboard as we have with decarbonization in energy. We have a defibernization in the paper and board markets. Next one. So I have tried to use this information and compare here how does it really compare with the reality. So for 2019, we had a consumption of 408 million tons of paperboard. And if I'm using the private consumption index, I'm landing on 439. And if I'm using GDP per capita, I'm ending up with 496. And if I extend that to 2025, there is a difference of 100 million tons. So we should not just use the old factor of GDP per capita if you're going to make projections on how much we need in the future. And also what's happening now is that the companies are setting new sustainability goals. So quite recently, Kimberly-Clark, which is the world's biggest producer of tissues, and saying that we will reduce 50% of the northern forest fiber footprint by 2025, and that means our sulfite pulp we are producing in the northern countries. And other companies are going to be forced to follow this development. Next one. We have the different fibers used in the paper and paperboard. And if you look at the blue line, which is going from rather lower level up to the top level of 24 million tons, that is bleached eucalyptus kraft pulp. And the green line is the pulp we are producing in the northern countries. So the dominating pulp in the pulp and paper market is the eucalyptus pulp. And we take the next one. And we can see that if you look at the pulp we are producing from softwood fibers, there is one market growing, and that's China. And the other markets is more or less stable. Next one. So taking into account the volume dominance by the eucalyptus kraft, and we can see the prices, the result is that the eucalyptus kraft is in a way price setting for how much price we can get out of our soft fibers. And what's happening is that the industry is replacing softwood fibers by eucalyptus kraft, and they are mixing to a higher degree the hardwood fibers with the softwood fibers in the products. Next one. So we can't look at Sweden in isolation. We have in the southern hemisphere fast-growing plantations. And currently we have a growth of good fast-growing plantations producing timber of about 1 million hectares per year. And if we assume that we have an annual growth of 30 cubic meters per hectare a year, that means 30 million increase of wood supply. And there are areas where we have a growth up to 60 cubic meters per hectare a year. But that means in 3 years, they are supplying as much as the Swedish current harvest. And there are signs that it could be 2 million hectares per year, because the financial industry is now investing heavily in sustainable renewables. and we have learned to handle the social problems with the plantations. Next one. But we also have the issue of competitiveness. And here I'm using our softwood sulfate pulp, the northern pulp. And the top part are all of the producing mills in the world. And each bar is a mill or mills having similar costs. And the bottom figure are the 3 dominating countries or regions producing softwood kraft, and which is, corresponds to around 85% of the world production. And what we can see are big differences in the production cost. So Sweden is in that category of Western Europe, and we can develop this kind of stairs for all of the grades we are using in the pulp and paper industry. And I have used that. Next one. Just for Sweden, where I have taken the technical description from a Lockwood Post Directory of Pulp and Paper Mills. It is a 2-brick thick report which you can buy for expensive money every year, and used the stair technology which I showed in the earlier picture. I've taken into account the technical age, how the product demand is developing, the environmental pollution problems, and within a 10 to 15 year time horizon, about a dozen mills will become obsolete in Sweden. And if we're looking at the wood consumption, that corresponds to 13 million cubic meters solid wood under bark. That will partly be picked up by other capacity expansions, but far from all will be picked up.
Sten, 3 minutes left.
Yeah. Next one, yeah. It's a lot of discussions that the paperboard, that is the future, that will take care of all of the problems. And the fast-growing packaging is the key issue. But if you look at containerboard, which is the fastest growing quality in board, the lower line of the darker blue, that is what is using virgin fiber. And that is rather stable over time. And the other one, the light blue, that is the recycled fiber. And that is what's growing. So you cannot simply take the growth of the paperboard and say that will affect our demand on virgin fiber. Next one. So if you look at Sweden specifically, we have lost a lot of graphic paper capacity. We have lost about 3 million tons in production since 2008. We have increased our paperboard production, but it's nearly 1 million tons. So we have lost capacities during this year, compensate for that. And the industry is saying that we are not efficient with our production of paperboard, and we can reduce the fiber consumption by 30 to 50% in 10 years. Next one. Yeah, this is lumber. And when you look at this picture, you think it is the development of Bitcoin, but it isn't, it's Woodcoin. And we have had a tremendous increase in the prices recently due to a dramatically increased demand due to the corona. because people have been home renovating houses. And this will go down. The question is how far down it will go, but it will definitely go down. Next one. Yeah, Ebba spoke about the demand on liquid biofuels. And we have done analysis from an economic point of view, and the only way we can see is that you're using the buy streams in existing pulp and paper and sawmills. And by that, we can see that there is economy in increasing 7 to 8 terawatt-timer during the next 10 years, which corresponds to 10 terawatt-hours of biomass. It may be another 7, 8 for up to 2050. Next one. We should also remember that the Forest Agency has suggested a number of measures to increase the forest growth, but there are no economic analysis of it, and that will increase the marginal cost. And I have here tried to illustrate the relative cost for the industry at the coast side for northern Sweden and compare it with the imported wood cost. And as you can see, the imported wood costs are competing with using the most far away locations from the forest industry in Sweden. And we can expect that this may increase in the future. Next one.
Sten, I must ask you to conclude.
Yeah. Can you, Peter, can you continue to flip through? Next one. Next one. Yeah, we can go to next one. So what I see as the critical issues in total is that any decent study of its forest sector's climate utility and contribution to biodiversity and other functions of sustainability needs deep studies of industrial structures and the markets. So the question is, what is the optimal economical and environmental capacity of the Swedish forest industry? And for sure, it's not economically or environmentally sustainable to harvest the complete available growth. We need a security margin, not at least in the times we are seeing the effects of the climate change, as we heard about yesterday. And it's not relevant from a societal point of view just to deliver the demand of wood the industry wants. They will always ask for more and on their conditions. Thank you.
Thanks a lot for this very comprehensive presentation, looking at demand from a slightly different perspective, and in particular market conditions and imports versus own production. I have quite a number of questions being posed. And the first question is really to Ebba. Have you discussed, if we assume that the demand that you predict is going to happen, have you discussed what policy instruments to use to make sure that you optimize the use of biomass in the areas where the greatest climate benefit will take place?
Well, I mean, we do expect that the demand will increase, maybe not as much as I presented on my slides, because I mean, we see that that's not possible. The demand can't increase that much because we can't meet it with the potential. And we think because the demand will increase and therefore also the price will increase, as Sten was saying also. So we think that I mean, in some sectors, there are policy instruments already today that steer the biomass towards these sectors. I mean, specifically the transport sector. So I think there will be a combination of expecting the market solutions to solve this. I mean, because the price will be elevated and the biomass will be steered towards the sectors that have the highest will to pay. But we need to complement this with some policy instruments as well, just to, I mean, weigh out these other policy instruments that we already have, and also maybe steer some raw materials exactly, for example, from Sweden to make biofuels of them, because now they're just left in the forest. So maybe we need some policy instruments as well, I think. So a combination.
Thank you. Well, Sten and Thomas, you presented two quite different futures. Maybe Thomas, may I start by asking you what is your response to Sten's analysis?
Well, I think that what Sten is trying to do is to put in market perspectives and what is probably will happen, given that we have a market regulation like we have today. What I did was that I presented a future where I assumed that there would be business as usual. So it's a bit of different approaches. So it's in my future, the area of set aside was fixed to what is the area today. The growth and the silviculture practices was according to what is common today. So it was like it's definitely a business as usual scenario. And what Sten emphasized is that there is actually no business as usual in the future. It will always change. Also, that will change. So in that sense, I think you have to combine the two futures and draw your own conclusions.
But business as usual never really happens. And we are living in a time of exponential technology changes that have already affected economies dramatically. Demand for paper, for instance, has been reduced because of that. And
but that's true. But I mean, it's the forest system is a very slow system. So when reality changes, it changes fast. But the forest landscape, it doesn't change according to other changes in the society. That is why it's kind of it's very difficult to forecast what is the best management strategy, because you don't know what the demand will be in the future. But this is what we have been living with for more than 100 years. So I think we just have to realize that this is a fact.
But let me ask both Sten and Thomas, if we expect more demand and the bioeconomy to emerge, one thing is volumes of biomass, another is innovation, how to use biomass in a more efficient way. I didn't hear much, Thomas, in your presentation. And Sten, maybe you can add to that also. What role does innovation play here?
Yeah, if I start, the innovation will be the key issue for the future, and the sector must be on its toes with the innovations in order to survive in the future. And we can see that the artificial intelligence will have a lot of impact on how we are managing, or the possibilities to manage our forest, and we should of course utilize that. We see innovations on the product side, and one important component in the definition of bioeconomy is of course that you should use your resources much more efficient when we are compared to what we are doing today. So it means not increased consumption of raw material, it means decreased consumption of raw material, and the innovations are working in that direction.
I think I completely agree with what Sten is saying here, that it's in a shorter term, it is it's innovations and a more efficient raw material use that will help us out. In the longer term, that can then be supported by increased supply of raw material, if you understand what I mean. But it's a much shorter process to work with innovation and develop, you can call it a circular bioeconomy. That you need a shorter time to make that change happen than to increase the forest growth by 50%. So, but I think you have to work with both in the very long term.
Ebba, how much do you factor in innovation in your strategy?
Well, I mean, we count with the innovation, and we count them as to help us in the transition, of course. And what we've learned is that, Svante always say that it happens much faster than we expected, and that's the role that innovations play here. So I think that when you're talking about what kind of investments that you need to do in Sweden now to make this demand and potential match, and how to use the Swedish forests more efficient, I think that you need to be flexible in the investments that you make to take account for innovations that will happen that we don't know about today, so that you have a flexibility in these investments to take the next step. I can't find but to transform the development of biofuels, for example, for something else when the demand for the exact that product is diminishing.
Thomas, you said towards the end that with the silviculture, almost anything is possible. And you implied that we can intensify harvesting and growing biomass, while at the same time meet all our international environmental commitments. Is that based on your hypothesis, or is it based on studies, or how shall I interpret that?
I think you should interpret it as it is possible. It's the limiting factor is not photosynthesis. It's not that the biological system as such is the real limitation. What is limiting is the societal license to operate and the financial situation. As I think Sten clearly showed, this is business also. So if you have an unlimited amount of resources, then it's true that you can almost do anything with silviculture. But if you are going to operate on a financial market that is functioning, then the limitations will be others than what is related to biological production. So it's more a question of how much we want to invest.
But you are implying large-scale cropping systems, and I fail to see how biodiversity concerns can be well managed in that. Sten, what's
then
your
you
point?
can't do it on the same piece of land. Then you have to differentiate the land use. So you have set-asides, and you can say production sites. But this is a question about values and attitudes in society. It's difficult for me to say what I don't want to prescribe what is right or wrong. That is up to other people to do.
Well, but you are an advisor.
Yeah, I can give you an advice if you tell me where you want to go.
Okay, Sten?
I think we are going back to what I said in the beginning. It is important to have the right systems perspective. And I agree with Thomas that we are coming from different avenues here, and we need to include both avenues in analyzing the future here with respect to carbon. I think there are one issue which hasn't been stressed, and that is the timing aspect. If we are going to help the climate, we have a short window. And the analysis on the carbon sequestration or the carbon balance of the forest sector has to be developed, that we are showing how it will impact what the climate or what the atmosphere is seeing in the next 30 years. And that is not very often discussed. So that is important. With respect to the management, I think we have clear signs that we are already today having an over-intensified forestry. If we look at the thinnings, we are over-harvesting according to the production manuals, the final fillings met up to 50%, which means you have less forest going into the final harvest. We are reducing the final harvesting age. And here in this area I'm living in middle Sweden, we are now down seeing that their harvesting stands in the age of 60. Mm. And if you're looking from a carbon point of view, you should not harvest the forest until they are reaching the maximum of the average growth. So that is one side of it. And the other side is that we have to promote the biodiversity, not only by setting aside, we need more set aside forests, but that is somewhat like Skansens, and that is not enough. And we have to deal with the biodiversity in the production forests, and we don't really know the relation between the biodiversity and how we are improving the functions of the ecosystems and the resilience. But that is the way we have to go. And we have to, I'm convinced that we must go in the direction of landscape management, where we are doing different things within the landscape, where we have set-asides, where we have intense forest, and we have mixed forest, and we have deciduous forest, in order to balance this out. I also think that, and it's in line with what Thomas is thinking here, that it's very difficult to optimize the management based on all of the demands we have on the forest. And in the end, it will be an issue of ethical and moral questions, what way we are going.
One last question, because we have to conclude, unfortunately. We could go on for hours. Sten, you showed demand for lumber going up over the last, say, 18 months, and you related it to the pandemic. We have an ongoing debate in this country that more of building and construction should be in wood. Don't you expect demand there to grow significantly, and that also could be an export industry for Sweden? I put the question to the three of you.
Yeah, I think we should be in the lead in the development of the new construction systems and wooden buildings, and it is the technology we mainly can make money of and export. Unfortunately, we have been talking about the increased wood buildings for the last 30 years, and not that much is happening. And I looked into the statistics the other day here. single-family houses have decreased. The new buildings of single-family houses has decreased significantly the last 3-4 years.
Oh, but I was talking mainly about high-rise buildings.
Yeah, okay.
Thomas, what's your view?
I think that the future building systems will be smarter. They will be a building system will be in such a way that it will be recyclable, fully recyclable. I mean, it's today when you take down a wooden building, it goes to bioenergy. But it's the material as such is really of high quality still, but we don't afford to, so to say, to reuse it. But if you make this, if you build your house from the beginning to be recycled, you can use the same material to several generations of buildings.
Yeah,
that would significantly increase. You can call it then the substitution value of wood buildings, and dramatically also increase the raw material efficiency in a way that the same cubic meter will then be enough for 2 or 3 buildings instead of 1 building. That could be a game changer, actually.
Thank you. Last word to Ebba, and then we conclude.
Okay. Yeah, I'm just going to agree with Thomas there, because I'm working a lot with municipalities also, and they are now trying to start to work even more with demand recirculation when they building buildings, and also they have the high demands on building in wood. So I think that's
going to increase.
Yeah.
Okay, fine. Thank you, the 3 of you. Very, very interesting session. A lot of questions remain for later today. Lars, I hand over to you.
Yes, so thank you, Anders. This has been very interesting. And of course, we have now overdrawn a bit, like 7 minutes or so. So I think we take a short break and be back at 1:05, so 25 minutes to 11. So just 7 minutes. So we'll soon be back. So see you then. So hello again, everybody. We now continue on the second day of this interesting webinar on the boreal forest and climate change. And now we have a very interesting topic, carbon reduction potential of forest products. And Anders Wijkman will also here be the moderator. So please, Anders.
Thanks a lot, Lars. Well, we did touch upon substitution quite a lot in the first session. And there were a lot of discussions specifically about Sweden and future demand of forest materials. And now we will look more specifically into carbon reduction potentials of forest products. It should perhaps have been fossil carbon reduction potentials in the title. So the question is, what do we use forest materials for? What are the climate benefits more specifically? What is the right level of harvesting in relation to the forest sink and various forms of substitution? That will be the major challenge for policymakers and for everybody involved in this sector. Our speakers are 4. First out will be Göran Berndes, professor at Chalmers, very actively involved in IPCC work, notably in the most recent land use report that was presented last year. And Göran has devoted lots of time to research on substitution. And the title of his intervention will be Forest Products in the Transition Towards Climate Targets. Second out is Giacomo Grassi from the European Commission and Joint Research Center. Giacomo has been intimately involved in issues related not least to the role of bioenergy And the title of his intervention is Forest Bioenergy and Carbon Accounting. The third speaker is Professor Sampo Soimakallio at the Finnish Environment Institute. And his title is very simple: Does wood harvesting help in climate change mitigation? And last speaker out is Mike Norton, professor at several universities, since many years director of the environment panel of ESAC, the European Academies of Sciences Advisory Council. And the title of Mike's intervention is Optimizing the Value of Forests to Humanity, a Challenge for Science and Policy. So we do, as we did in the following session, your interventions first and then questions and answers. And again, I tell the audience, please put your questions under in the link questions and answers, not in the chat. So, Göran, the floor is yours.
Thanks, Anders. Just give me a sec. Okay, so thanks, Anders, for introducing me and for letting me participate here. I just came from another webinar on similar issues, so I'm sorry that I haven't heard the first session. So if I say things that are repetitive, you might just tell me to maybe speed up. So this is the title I got for this presentation. I would like to qualify it a bit by just kind of pointing out my approach to looking at climate change mitigation here. So there has been a lot of discussion now on substitution effects. Of course, that is one vital part of climate change mitigation, to reduce net greenhouse gas emissions by substituting fossil products with bio-based products, for instance. My entry point now is more towards the second interpretation of climate change mitigation here, and that is the systems transition, which involves a lot of things. So it's not the least changing technologies and infrastructure, changing land use practices, both to reduce emissions associated with land use, but also maybe to provide raw material for new products, and changing lifestyles. So many things. And it's this system approach that will be the focus for me. I hope it's complementary to what my fellow presenters will cover afterwards. But I just want to say first that this choice of focus is not because I am not interested in substitution. And I think it's very important to understand really the substitution effects of different choices of production and different products. And I think, for instance, LCA studies are really, really important for digging up detailed information. So the questions raised by our friend here is really important, but I do believe that they need to be complemented also with studies asking other questions and having a larger scope than this. I also believe that the focus, now I speculate, but anyway, the focus in the debate sometimes has been influenced by the way we evaluate substitution effects and applying a rather narrow approach to asking questions. And not the least, a consequence of that is that we have sometimes represented the complex system of forests and our way of managing them as just a strict sequence of events that in reality happen simultaneously all over the forest landscape all the time. And these events then, depending on how you look at these, you can make a very different conclusion on the climate effects of using different forest products. So it's illustrated by these two persons here that are having an argument about what they see. And one of them is really looking at the forest complex as a matter of first cutting a tree and then burn it and then plant a new tree. And he then concludes that we have a lot of CO2 emissions up front, and it takes a long time before a new tree has grown up to sequester all this CO2. And then you have the other guy that looks at another part of the forest, and what he sees is actually that there is some planting going on, and there are trees growing up that sequesters carbon, and apparently that means that they cool the world, which is great. And then in the end, after a long time, you cut down the trees and you burn parts of it, or maybe all of it, for energy, and then you kind of return the CO2 again to the atmosphere. So the cooling ends, unless you plant a new tree, because then you start cooling again. So completely different conclusions. And maybe I make it too simple now by really making arguments vulgar, but I think there is a hint of truth that the debate has sometimes moved into these polarized positions where we really push things in apart from each other. So I'm focusing on this perspective, the landscape approach, where we can get away from part of the problem with system boundaries causing strange representation of this complex system, but where we also can capture other aspects like actors and how forest sector responds to changing conditions and to changing markets over time, and how this in turn influence the development of carbon stocks. Then the questions, and I expect this will actually be the question raised by some of the other presenters also. The question will be how forest carbon balances are affected by changes in forest management because of changing production conditions and because of markets. But where I wanted to go now as the last part of my intervention is a bit broader than that, and that is the forest and the forest sector in the context of transition towards climate targets. And then just representing that with this picture that I expect most of you have seen many times. So it's from the 1.5 report. It's a typical illustration of the transition that we are aiming for, although we might want to have more or less of different things here. We might be more or less happy about having a lot of CDR, carbon dioxide removal, in the second part of our this century. We might want to have more or less of BECCS and so on. But qualitatively, this is a development pathway that I think many of you expect to see, but then with different relative importance of the different parts here. So when investigating how forests and forest products can contribute in transitions, and if you do it while looking at energy system dynamics, you learn, for example, things like this, where you have here, as an example, you have the European power generation over time. So you have capacity on the y-axis, you have a time axis up to 2050, and then you have evolution of the total capacity, where you see how the existing system, which is of course quite much fossil, is gradually phased out as a consequence of policies and age of plants and cost of different inputs, and instead replaced then by renewables, which is, as you see, dominated by solar and wind, and where you also see, maybe it's not really clearly represented here, but you also see a shift in the use of the bio-based part from base load generation together with other fossils to be much more of a balancing power supporting wind and solar, and actually in this case improving the economy of wind and solar, so pushing a bit for a stronger growth in wind and solar thanks to this balancing contribution. Another thing we learn when looking at system transitions, and that is that the development of new energy and transport systems, it really takes time, and also that the development process in itself is associated with greenhouse gas emissions. And then this observation, while also recognizing another very common way of describing the climate challenge, that we have a very, very small carbon budget remaining if we want to stay within 1.5. It's a bit larger, of course, if we want to stay below 2 degrees. But it's anyway this recognition that development takes time. It might also require some claim on emission space, and the emission space is quite small. That's really pointing towards big challenges. And we also see evaluations that are starting out from recognizing this very small emission space and also the limited time we have. We have evaluations and debates questioning some of the strategic developments and investments that we see, basically based on recognizing they will not happen fast enough, or they have a too high emission upfront of CO2 and other greenhouse gases. So this is really a difficult path to take. You have it in Sweden. We have a debate right now actually on the upfront emissions and payback times and so on of investing in large scale investing in train infrastructure. So exactly this. I'm sure you have seen quite much on the upfront cost of manufacturing batteries and the electrification of the transport sector, where you also have reports expressing concern about this happening too slow or causing too much upfront emissions that takes too long time to pay back and so on. So very similar to what we have in the discussion about forest and forest products. And I think that this requires us to take a kind of a strategic view on how to use what you could refer to as remaining emission space, or how to use a carbon budget, and really reflecting on the fact that that transition itself might actually require some of the space for emission. And I would dare to say that it's probably so, if we relate to 1.5, that we will overspend the budget. So part of the transition will cause us to overspend the budget and possibly reaching temperature targets from above rather than staying below all the time. How am I with time, Anders? Should I stop, or I have a simulation of Sweden, but I can stop here if you like.
No, you have another 3-4 minutes.
Okay, then we do my simulation. So just linking to this view on emission space and how to navigate within emission space, I wanted to show a few figures from a paper we did some years ago, where we calculated the national carbon budget from a global one, which is of course not straightforward, and it involves a lot of decisions about views on historic emissions and a fair distribution of emission space and so on. So you can do this in many different ways, and I do not propose that we did it in the right way, but we did it in one way that is similar as others have done. And this is what you see here, the Swedish CO2 budget. If we are to have 66% chance of staying below 2-degree warming. And I start with the business as usual, where we look at both fossil emissions and what happens with the land carbon as a consequence of how we manage our forest and how we change our land use. And this is territorial now, so territorial carbon balances. So 2025, we have quite much of fossil emissions, but we also have sequestration of carbon into land. So the net effect in Sweden looks like this, 2025. Still some emission space left. If we would move further along business as usual, it doesn't work. Our strong forest carbon sinks will not save us from having to make a drastic transition. So this is how it looks. And then if you look at then responses to this, of course, you see huge changes in transport and infrastructures, part of that requiring quite much more of wood supply for raw materials and also for energy purposes. And we made a few scenarios on that, which I show here just as an illustration of possible pathways, where you will see here in this case, specifically for Sweden, so it's really not something you generalize to all other places in the world, but here, if we have this really, really strong transition in energy industry transport, as were included in scenarios for the Swedish climate neutrality target, we can reduce emissions very significantly. Biomass is used more than we have used it up until today. At the same time, depending on how we manage the forest, we can have a similar carbon sink as we have had, or we might even have a stronger sink, as you see in the rightmost graph here. So this was just as an illustration to show how one can think about emission space. I think I'll stop there, Anders.
Thank you. Thank you, Göran, for this presentation. We'll come back to questions later on. One comment from me only is that I don't think most people realize that when IPCC defines the carbon budget for 1.5 degree of warming or 2 degree of warming, in reality, they calculate with 66% probability to really meet the target. And it's, in my opinion, quite strange, because in what other activity in society are we aiming at such low probabilities where the consequences are so dire? But that was just a side comment. Now, Giacomo, I know you've had some problems with the internet connection. I hope it will work. You are mostly welcome. The floor is yours.
Thank you. Just let me know if you experience some problem in looking at the slide or listening to me. So could you please confirm that everything looks okay? Can you see the screen?
Everything is fine.
Okay, excellent. So good morning to everybody, and thanks for inviting me. So this presentation is based on a recently published GRC report on the energy use of woody biomass with a long list of authors, and which covers also aspects not specifically addressed today. So the aim of this report was to inform European policymakers during the review of the most important legislation on bioenergy, which are RED II and LULUCF. The topic is important because more than half, as you know, of the renewable energy in Europe comes from forest biomass. I will focus here on the carbon accounting aspects, and I will also anticipate that I will only partly enter in the ongoing debate on RED II revision, because it pertains more to policy rather than science. But before moving forward, let me advertise a recent brief that complements the GRC report on bioenergy, covering other aspects of forest mitigation that are anyway relevant also for the discussion we're having today. So I'll start you by giving some general information from the report. First, studying the flows of wood products is very complex. On the left, you see a simplified representation. Wood, both as primary or secondary use, can be used both for energy or for materials. On the right, you see a much more complete and complex version of these flows described in the report that I will not analyze further here. An important message that I want to give you here, however, is that the uncertainty of the data is quite high. At the EU level, statistics on the uses of wood gives value that are about 20% higher than the statistics on wood produced. In short, it is not clear where a substantial part of the wood we use comes from. And this is a big problem for any policy we want to implement for bioenergy. Overall, about half of forest bioenergy comes from secondary wood. This includes processing residues, bark, end-of-life products, and also 4% of imported pellets. The rest is primary wood, especially fuel wood. And a substantial share, as I said before, about 20%, is of uncertain origins. Looking at the trends, can be seen that up to around 2007, the increase in fuel wood and industrial roundwood, you can see below the red and green line, followed the gross domestic products. After that date, the increase in fuel wood became more pronounced. Let's move to the carbon accounting, which is the topic of this presentation. So first of all, you can see here that the combustion of biomass for energy in Europe is responsible for about, let's say, 360 approximately million tons of CO2, which is equivalent to 9% of total EU emissions. Essentially, the red and dashed blue line here, which are calculated with different approaches. If this biomass were not burned, generating the same energy with the current energy mix would produce emissions of about 260 million tons of CO2. Here we already see something which is quite well known. The fact that biomass produce more emissions per unit of energy produced compared to other sources. However, it would be wrong to draw conclusion just on this observation. What matters is the type of wood that is burned. One thing is to burn residues whose carbon would soon return to the atmosphere. Another thing is to burn stem wood that could have potentially a better use from a climate point of view, including leaving the stem wood standing in the forest and continue to grow, or use it for long-lived products, replacing energy-intensive materials. The data that the GRS report indicate that most of the forest bioenergy used in the EU is based on residues, but there is room for improvement. But about the 33% increase from 2005-2018, which is a substantial increase for bioenergy, is mainly associated with firewood. And what is most worrying from my perspective is the great uncertainty in statistics that that prevents assigning a high confidence to any conclusion. The RED II directive lists a number of criteria that forest bioenergy must meet in order to be counted toward the renewable energy target of each country and also to access incentives. I don't enter in the details of the criteria here, just say that the next slide will address the carbon accounting criteria, which is what links RED II with the LULUCF sector. So links RED II with the EU climate accounting. Let's start from here, where the carbon impact of bioenergy is accounted. We heard some discussion yesterday on that. Bioenergy emissions are not counted at the time of biomass combustion because they are already counted in LULUCF, when the tree is cut, as a change in carbon stock, reported annually in the greenhouse gas inventories. This is the approach adopted by the IPCC and UNFCCC for their inventory, with the aim to ensuring feasibility, practicability, and avoid double counting. And we heard some criticism to this approach yesterday, but just think, how would you ensure an accounting under the energy sector without a double counting LULUCF? In my view, would be very difficult, if not impossible. Why? Because the biomass burned for energy comes from very different and complex pathways. Some is wood harvested a few months before, other harvested years before. Other wood is end-of-life products harvested decades before. Since the LULUCF sector reports the annual change in carbon stock, and there is no other way to do that, accounting forests under the energy sector would imply a retrospective and frankly unrealistic attribution of what has been burned to a biomass harvested in a specific past year, and would imply an ex post subtraction of this harvest from the LULUCF accounting to avoid double counting. Once clarified where bioenergy is counted and why, there is a rationale behind that. So there is nothing to change, in my view, in the EPC guidance in that respect. Let's see how this accounting is made. And this is crucial, of course, because the way it does accounting affects much the credibility of the whole system. As we heard yesterday, variations in emissions removal from LULUCF will contribute toward the achievement of the EU climate objective by 2030. LULUCF regulation defines how to count these emissions removal, specifically through the reference level. Reference level are country projections against which future emissions will be compared. You see here the historical sink we have seen for Sweden. This is for all Europe. The historical sink, the reference level is this red line. If the sink will be smaller, so negative numbers is a subtraction of CO2 from the atmosphere. If the sink will be smaller, there will be a debit. It has to be compensated by extra emission reduction in other sectors. If the sink will be bigger, then part of the sink with some limitations can be used to help other sectors to meet their objective. The reference level has been designed to reflect the impact of changes in management relative to the historical period. And the impact of this change will be reflected into account. Of course, trade-offs exist between harvest and bioenergy, because harvesting more for bioenergy would allow saving some emission in the fossil fuel sectors, but on the other hand, may lead the sink to go below the reference level, and then the country will incur in a debit. So a careful assessment of what is the harvest plan should be made to avoid that at the end extra harvest doesn't pay off. This shows that claims that the EU assume bioenergy is carbon neutral are incorrect, or at least outdated. However, as you can see here, reference levels do not include the impact of increasing harvest. The ration of the increasing harvest due to age-related dynamics. The rationale for that was not penalizing countries for their age structure dynamics, which is determined by choice made by our grandfathers. While the increase in harvest in reference level is somehow in line with the historical trend, the corresponding decrease of the sink, because we see the reference level for a 16 increase in harvest and a corresponding decrease of the sink by 17%. This is a reason of concern, especially in the light of the new climate target established after this regulation, which is the minus 55% in 2030 compared to 1990, and the climate neutrality in 2050. These new targets require reversing soon this current declining sink. And this is a challenge for that we heard also in the previous presentation. LULUCF in itself does not guarantee a positive climate output of bioenergy. This is because poor communication and possible mismatch of incentive can produce negative results. On the one side, we have read that consider forest biomass as renewable and encourage economic operators somehow to make an increasing use of forest bioenergy, stimulating demand for wood in the short term. LULUCF, on the contrary, in the medium term, gives a signal to the country and say essentially, be careful not to harvest too much because you may exceed and you may incur in a debit. However, if one reads country report like the National Energy Climate Plan, the impression is that many countries still don't fully understand the links and trade-offs between RED and LULUCF. The concern is that the bioenergy demand will drive an increase in harvest beyond the control of the country, with possible negative consequence for the forest sink. Speaking of harvest, when we present this report on bioenergy, typically we are asked the question, why the JRC bioenergy report indicates a moderate increase in harvest according to country statistics, while a paper still published by JRC report a much stronger increase. This paper, which is Ciccherini et al., used remote sensing to detect forest cover loss in the EU and triggered a very controversial debate, I think especially here in Sweden. Since I am a co-author of that paper, let me offer some clarification with aim to detoxify a little bit the debate. The short answer is that this Nature paper measured clear cut and not total harvest. Unfortunately, and it was a communication mistake, it was not clear in the abstract, but it was explained 5 times in the text. You can see here the text that has been used to explain that the study focused on clear cut and was not able, with the remote sensing image used, to detect, for example, thinning and selective logging. We also had a specific information for each country. Here, I just put the one of Sweden, saying, according to Swedish statistics, about 37% of harvest comes from final felling, which is what we measure. And this explained the lack of correlation between our estimates and total harvest removals. We also, in our press release, made it very clear that we only look at clear cut. Again, it was unfortunately not clear in the abstract, and this created a lot of confusion. You can see also further clarification in this extra paper. And this slide aims to clarify the big misunderstanding associated to that paper, a misunderstanding which flamed the debate around that paper like really benzene on fire. This is the original main figure of the paper. In red is the increase in biomass. The critics of the paper interpreted this figure like if it was total harvest and compare it with country statistics like this figure here. Such an increase looks impossible and clearly contradicting country statistics. And we have been highly criticized for that. However, everything is wrong in this comparison. It's not even an apple to orange, it's an apple to elephant comparison, because it compares tons of clear-cut felling with the cubic meters of total removals under bark. Apparently, it turned out that our critics didn't notice the y-axis of the figure, which is biomass, tons of biomass, and not cubic meter. Let's be clear. No doubt that the paper should have been more clear. It's a lesson to be learned. But if one criticizes the paper, it could be expected that the y-axis of the main figure is understood. It says biomass. So here I make an apple-to-apple comparison. So translating biomass in cubic meter and transforming removals from countries into felling, this is an apple-to-apple comparison. You can see that when latest reliable statistics on country statistic of harvest, this is exactly the blue lines as the JRC bioenergy report, based on country statistic of felling, using also information on wood use, not only wood harvest, so wood use, but the blue lines are based totally on country statistic with a given uncertainty I explained before. So that paper, Ciccherini paper, the red line is much lower because it focuses on clear cut only. The rest are small scale activity not included in the JRC paper. Finally, as you probably heard, a change in algorithm in the original global forest change dataset emerged after the year 2015, after the paper was published. This change made the algorithm more sensitive to small-scale forest activity, and therefore, after 2016, harvest from clear cut has been overestimated. As it is now abundantly clear, this change in algorithm was totally undocumented. Nobody but one was aware of this. This is a glaring error of the dataset developers, which partly misled these and dozens of other studies. Once the impact of this problem has been taken into account, we have the orange line here. The increase in harvest from the original study remains, but is not as abrupt as originally suggested. So overall, the available evidence confirms an increase in clear cut. But of course, any further check of this result is welcome. Science advances with progressive improvements. And I hope that also here we have better evidence soon. So once clarified, there is no necessarily contradiction between the GRC bioenergy report and the GRC study on forest harvest. Let's come back concluding on our main topic. If I manage. Okay, so this is the apple-to-apple comparison. Okay, conclusion. So several views and concerns are legitimate on the impact of forest bioenergy. I'm a bit allergic when I say science is this or science says that. Science may say a lot of things, but cannot solve all the problems in bioenergy because some of the problems are linked to values. So far, the most explicit suggestion for addressing the concern on bioenergy have been the following, and just consider a brainstorming as an input for the discussion. Some say stop considering bioenergy as carbon neutral. Well, again, bioenergy is not assumed carbon neutral. It's not a relevant criticism. Count emission from biomass burning at the point of combustion. Again, it would be very difficult to avoid a double counting loose here. This is not the key issue. Then another comment is, let's legally restrict the feedback to be used in the energy, like residues only or given diameter. This is a fully logical concern. What I note here is that the previous impact assessment already assessed that options. Of course, now it could be the time to reassess. It is fully legitimate in the light of new evidence or the new values or the new sensitivity that we have. But it was just outside the scope of the GRC report. Or some say even stop considering woody biomass as a renewable source of energy. Of course, this would reduce all the risk of negative impact, but would also reduce the opportunity of positive impacts. So my point is that risk of negative climate impact when using bioenergy exists. Let's be clear, exists. I think an effective implementation of existing EU and especially national policy may help reducing this. If this is enough or not is mostly a policy decision. And the last slide is that I think that a constructive contribution from the scientific community would imply integrated modeling all the mitigation potential from forest, including both the sinks, carbon stored in HLBP, material and energy substitution, taking into account biodiversity and economic aspects. Rather than saying bioenergy is good or bad, I think the scientific community should try to say under which condition bioenergy can be used for or not. From country size, I think that there is a lot to do. A smarter use of bioenergy would require a greater awareness of the RED and UCF links and trade-off. And based on this awareness, countries should implement governance tools, policy incentives, economic incentives that are coherent with the climate target and encourage win-win and discourage lose pathways that are already available in the literature. And finally, a more timely and reliable monitoring of the use of forest bioenergy is a must, because without having confidence on the data, you can implement any kind of policy. Thanks.
Thank you very much, Giacomo. And you, in fact, you covered two reports, the bioenergy report, but also the report that was published in Nature. Okay, we will come back to questions later on. Now, Professor Samakali.
Okay, thank you very much. Can you hear me?
Yes.
Very good. And can you see my screen?
Perfect. Okay,
great. So, good morning or afternoon, whatever it is. In Finland, it's afternoon. So I would like to talk about basically the trade-offs between carbon sequestration and substitution. And through that, I would like to respond to this question of my title, that does wood harvesting help us in climate change mitigation? So starting from the very basics, and which is also quite the same what Göran Bernd has already shown, we know that we need deep cuts in greenhouse gas emissions, and we also have to enhance our carbon sinks at the same time. And of course, the emphasis must have to be in the emission reduction side, but at least in theory and in principle, carbon sequestration and emission reductions are alternatives to each other, at least to some extent. And it's also shown in this figure that the faster we cut down the emissions, the less we need carbon sequestration, and vice versa. And then the key question that how forests actually use in this picture is that we know that, okay, managed forests, they typically sequester carbon, so they act as a sink, and thus they can be utilized to enhance the sink function, but they also provide us wood for societies which can be used in place of fossil-based materials and energy, and that way cut down the greenhouse gas emissions. And I think there is quite much confusion related to the substitution and what substitution basically means. And the problem from my perspective is that many people seems to think that these two functions take place at the same time. So even if it is true that managed forests act as a carbon sink if they sequester more carbon than they release, and they also do provide wood for society, we still cannot combine these two functions together. So we cannot add carbon sequestration and avoided emissions through substitution together. And why is it that? It's basically that if we consider that there is a current situation where there is a managed forest which act as a carbon sink and provide wood for society, and then partly this carbon from wood is released back to the atmosphere when we use wood, this creates a kind of carbon balance. But we also have alongside with this forest biomass use, all the fossil-based material use and energy, and it exists there. So if we would like to reduce the use of fossil fuels, with wood, we need to increase the use of wood. And when we increase the use of wood, we can cut down the emissions of fossil fuels, but at the same time, very typically, the forests then act as less carbon negative. So the sink function is weaker in such a condition. So this leads us to the question that, okay, if we would like to respond, if we would like to understand that, that whether increasing wood use helps us in climate change mitigation or not, we need to understand the overall carbon balance, like Giacomo also mentioned. So the key question from my perspective is then that how the forest carbon balance is changed when we increase the use of wood, how the harvested wood product carbon balance is changed, and how the fossil-based emissions are changed. And we can, as we know that there is a lot of assumptions required to respond this question, and there is also dynamics involved in forest carbon balance development. We can also ask the further question, which also mentioned by Giacomo, that under which conditions increased use of wood mitigates climate change or does not mitigate climate change. So I will now show a few quantitative results or ranges, which are basically based on these two papers, one which is published this year with my colleagues, and the left-hand side paper is published 5 years back. So then how can we characterize the results? So I will separate these into 3 main baskets and characterize all these baskets through dimensionless indicator, which basically tell us that what is the carbon emissions, tons of carbon emissions per tons of carbon in harvested wood. So first of all, we can analyze by comparing two different forest management scenarios, one in which we harvest more wood and one in which we harvest less wood. That what is the difference between these scenarios in forest carbon balances? And we can calculate that and compare it with the additional carbon in wood we harvest from the forest over a certain period of time. Secondly, we can make the same thing and calculate that how the harvested wood product carbon stock is changed and compare that with the carbon in harvested wood from the forest over a certain period of time. And finally, we can calculate in the same way that what are the avoided fossil carbon emissions per carbon we harvested from the forest over a certain period of time. Now considering first the forest part, so first of all, there are quite many forest management scenarios carried out in Finland in recent years. And they also show and different types of harvest rates has been considered in those scenarios. The current level, which is typically something like 60 or 70 million cubic meters, or increasing the harvest rates up to, let's say, 80 million cubic meters, which is a kind of national target in Finland, or the maximum sustainable yield, or a significantly lower level of harvest. And in some scenarios also the baseline scenario has been set so that it's corresponds no harvest at all. Also, it has to be kept in mind that in some scenario studies, only the harvest rates has been varied between those scenarios, but in some studies there are also other factors changing. For example, there can be some nitrogen fertilization or planting with genetically improved material, and in some studies climate change effects has also been considered. So what kind of conclusions can be made from these scenario studies? Basically is that the typical range when considering this indicator, how much forest carbon balance is reduced when we increase the harvest rate. So typical range is something between 1 to 2 over short or mid-term time horizon. And if we consider longer time horizons, this typically declines this effect, but some studies also show that it can be up to approximately 2 tons of carbon per tons of carbon over 100 years time horizon. In those studies in which climate change has been considered, especially if climate change has been considered as a factor to boost forest growth, actually, the value of this indicator becomes higher because there are more foregone sequestration encountered in such cases. And the lower values can be seen from those studies which include some compensating factors like fertilization or planting with genetically improved material. And also, one conclusion is that in those studies in which no harvest creates the baseline, then typically the value of this indicator is lower and can be something like below 1 tons of carbon per tons of carbon. Now, just to compare these values to the typical increase in harvested wood product carbon stock, we can see that what happens in forest is significantly higher compared to how much we get typically carbon to remain in the harvested wood product pool. Now, when we then consider the products and the substitution part. So first of all, of course, we know that there are different types of wood assortments we take out from the forest: sawlogs, pulpwood, energy wood, and the amounts of these can vary between different scenarios. And we can produce very many different types of alternative wood products from them and categorize them into these typical main categories. And then we can substitute different types of fossil alternatives. And of course, there are some products like paper products for which it might be very difficult to find any fossil-based alternatives. But for many products, we can find some kind of alternatives, and there are differences, and it might be very difficult to say that what is exactly substituted by some kind of product. But based on the literature, it can be found quite easily typical ranges within this avoided GHG emissions vary. So we know quite well, at least the energy part, that how much fossil-based emissions can be substituted with 1 unit of biomass-based carbon. This is much more difficult, and there are more uncertainties when we go to the material side, but the typical ranges still are something between 0.5 and typically up to 2 tons carbon per tons carbon. And naturally, there are certain specific products in which these substitution factors can be significantly higher, but when we look at things at the average level, these ranges typically fit quite well. Then we need to take into account also that we have to use wood also for processing of these wood products. So we cannot convert all the wood into these final products. So here I show the typical ranges for how much wood is required to produce these end products. And of course, part of that wood can be then used as side streams for energy, but typically much of it is required as a processing energy to process these products. And that means that when we take all these into account and calculate the indicator towards the carbon harvested from the forest, we can see that it's significantly lower compared to what we see if we calculate the indicator just based on the carbon in harvested wood product. So based on our studies, we can conclude that typically the avoided emissions is less than 1 tons carbon per ton of carbon harvested from the forest. Now, when we combine all this information together, we can conclude that at least the decadal time horizon, even up to 100 years, the typical reduction in forest carbon stock when we increase the harvest rates is something like between 1 and 2 tons carbon per tons carbon. Part of that is compensated as an increase in harvested wood product carbon stock. And then we can, of course, have these avoided emissions when we use more wood. But when combining all these factors together, the conclusion based on our studies is that it's much more likely that the emissions are increased than decreased when we increase the use of wood. And considering different types of uncertainties, at least it can be also concluded that the significant decrease in emissions, for example, if we would like to see that each unit of carbon we harvest from the forest would provide us, let's say, 50% reduction in fossil carbon emissions or the overall net carbon emissions, that's quite or extremely unlikely to take place according to this quantitative assessment what we have been carried out. So coming to conclusions, based on that, it's quite difficult to argue that increasing harvest rates helps us significantly in climate change mitigation within this century. But like Giacomo also mentioned, and I fully agree that under some conditions, this might happen. And this is also something what Göran talked about, that in case this kind of compensating factors take place, like if we create more forests through afforestation or make some additional emission reduction measures to compensate the reduction in the inherent reduction in the forest carbon stock, what we see when we increase the harvest rates, then these conclusions could turn upside down. But we should also take into account that under some conditions, this might be even more challenging. So there are already incentives for alternative products, let's say fossil-based products, to decarbonize the production and use of those products. So that is also something that we need to keep in mind, that if those alternative products manage to decarbonize themselves, that makes this picture even more difficult, considering the climate benefits of wood use. Finally, I would like to remind that climate change and loss of natural biodiversity are both factors which clearly generate significant uncertainties to all these kind of analyses, and it seems that they are really, really difficult to take into account in robust way in this kind of quantitative assessment. So definitely we need improved understanding on that, but it's not easy to conclude that how these would change the results, because they apparently influence on both more and less intensive forest management, and they can the effects could be quite unexpectable for different types of forest management. All right, this was my presentation, and finally there is a list of references and also some further reading listed here. Thank you very much.
Thanks a lot for that. Food for thought, really. We come back to questions. Mike Norton, the floor is yours.
Thanks, Anders, and thanks for this invitation to join this webinar along with the world's leading scientists on boreal forests. The breadth and depth of talks I have listened to has been truly illuminating. And as you explained, I direct the environment program for ESAC, which harnesses the expertise at Europe's academies of science to look at the policy implications of science. And our agenda stretches from pesticides to oceans. But on this occasion, I will talk a little about our work on specifically on forests. The title of this session is on the carbon reduction potential of forest products. But this is just one aspect of getting the most from the limited forest resources for society and the environment as a whole. Managing resources that offer free goods such as biodiversity and carbon stock alongside marketable goods such as timber and energy is a societal and political challenge where science can inform but not direct policy. But as we face climate and biodiversity crises and calls for transformative change, we need to take a holistic view to optimize the benefits of our limited natural resources to humanity as a whole, and on a sustainable basis, not just meeting the demands of one or more sectors. I would like to share experience we have gained at ESAC in taking such a holistic approach and examining what is the appropriate role for forest biomass in energy production. Of course, there's no need to tell the current audience of the many ecosystem services that we receive from forests, from timber to biodiversity, from oxygen to carbon sink. Just listing those would take 2 slides. But managing the free goods that these provide alongside the marketable goods has to take place with sometimes fragmented and complex ownership system, and potentially strong and determined private economic interests, making the system of management very complex. However, most countries, especially highly forested countries like Sweden, have centuries of experience and tradition to build on. Well, when we did a major review of Europe's multifunctional forestry led by the Finnish Academy 5 years ago, there was a cascade of economic use illustrated in this diagram here. But these are flows determined by market signals up to 2010, and you will see at the bottom a fairly narrow output for biomass power plant use. But since 2009, when all bioenergy was classed as renewable energy, its use has grown and is continuing to grow. More recently, however, biodiversity and increasing carbon stock have become priority items. So this is clearly increasing the challenge to policymakers on how to balance these particular two issues of carbon stock and energy use. And these debates are rather active at both European and national level and also internationally. At the moment, as we've heard many times up to now, the subsidies go towards bioenergy on the assumption that this is contributing to climate change mitigation. In other words, like solar and wind, it should be reducing atmospheric CO2 levels. However, while a solar panel or wind turbine is a zero emitter once established, biomass emits CO2 when it is burnt, and unfortunately does so at even higher rates than fossil fuels, including coal, when used for electricity generation. We treat it differently from coal and gas and call it renewable because it is seen as part of the carbon cycle between vegetation and the atmosphere, and therefore can be renewed in a limited time. However, the atmosphere does not differentiate between a molecule of CO2 coming from coal, gas, or biomass. So we need to look scientifically at what is actually occurring. The problem with biomass is that every case is different. There is no simple unitary concept for a bioenergy system. Yet in the regulations, bioenergy is always renewable. In the upper case, I've just shown a couple of photographs from local use of residues which would otherwise go to landfill or left to degrade naturally, and have no other practical use, which are used in high efficiency combined heat and power. But this is classed equally from a regulatory perspective to the lower example, which is additional harvesting of whole trees, conversion into pellets, and shipped around the world several thousand kilometers just to generate electricity. Treating these in the same way from a climate perspective and scientific analysis is distinctly questionable, but this is what is happening in the regulations. So classing biomass as renewable has brought subsidies to use towards meeting national renewable energy targets. And another key advantage of using biomass is that emissions on combustion are not recorded in the energy sector, as we've heard several times. The net results of this is to have the current situation where across Europe about 6.5 billion euros are allocated to biomass subsidies each year. The emissions from the use of biomass have grown from around 192 million tons of CO2 in 1990 to probably approaching 500 now, and are about 15% of EU energy emissions. And while we can claim impressive progress in reducing energy emissions from the energy sector, in fact by 22%, as shown in the blue area of the diagram, this reduction would shrink to a mere 5% if we did not have that accounting rule that allows us to ignore the emissions in orange from bioenergy. However, the atmosphere doesn't mind whether we account for a CO2 molecule or not. These are all visible to the atmosphere, so it is important to look at the real climate effects, not just the illusions we get from accounting. We've done quite a lot of work on this over the years, and we started to question the scientific justification of treating biomass in the same way as wind or solar from a climate perspective. The key question is how and when a given energy source can reduce atmospheric CO2 levels. As we heard in the first lecture yesterday, biomass is associated with higher emissions per unit of energy than fossil fuels, which is compensated by its ability to reabsorb CO2 in regrowth. We are focused on the key question of how long it is before any initial increase in emissions is compensated for that by forestry regrowth, and that's what we call the carbon payback period that's been recognized in a couple of previous talks. If we focus on that carbon payback period, we realize we're talking about quite different lengths of time in different circumstances. Wind or solar, but restricting ourselves to renewable energy, wind or solar actually have relatively short periods before the zero emissions, when they start generating, start to compensate for the extra emissions in materials and installation. But with forest biomass, it's very, very variable and can vary from just a few years to never. So I'll just give you two examples of the extremes. One example here is of the use of local genuine forest residues, which would otherwise be remaining in the forest and degrading naturally, to replace fossil fuels in a CHP, high efficiency CHP. There, it only takes a year or so to actually get a net benefit to the climate. On the other hand, at the other extreme, you have the classic case of export of millions of tons of pellets from USA to UK, where we have the actual additional harvesting. It may be clear cut, it may be thinnings, but it's additional harvesting comprises a significant fraction of the feedstock. That goes to pellet mills, converted to pellets, shipped across the Atlantic, and then combusted to generate electricity. And this paper looked at that life cycle and the whole carbon balance and concluded that in the best case, you had a net climate disbenefit and for 75 years. And in the worst case scenario, that extra emission to the atmosphere relative to the original coal-fired power station would never actually be recovered. So with this gives you an idea of the huge range of possible configurations for bioenergy, which regulators have to deal with. We heard from Giacomo for the excellent and very thorough report that was released earlier this year by the JRC. A key figure here is the one shown here, and on the left axis you have the carbon emissions mitigation performance, and on the upper horizontal axis, effects on biodiversity. You will find via the scatters that relatively few scenarios actually achieve short-term climate mitigation, that's less than 50 years. Many have longer periods, and that the effects on biodiversity are also not generally beneficial. You can add to that work which has been already published in the UK on the particular source of biomass in the USA. And the uncomfortable conclusion of this is that quite significant proportions of current feedstock in the international trade, I emphasize here, do come from sources with relatively long payback periods. And that has to be compared with our current urgency that we've heard before in trying to reduce emissions to meet Paris Agreement targets. So broadly speaking, our conclusions that we've emphasized in various policy implications are that, the science really points to some rather uncomfortable conclusions. The large subsidies are making the climate problem worse in the immediate term, but without any obligation to receivers of the subsidies to demonstrate when they can make a net contribution to climate change mitigation. We've also pointed out misleading reporting of emissions, which allows importing countries to claim progress towards climate change that they do not really provide. Basing regulations on the science with a primary motive of mitigating climate change would require us to limit subsidies to those which provide us shorter term climate benefits and have much more transparent reporting. Of course, much of this is widely recognized by the Commission, and Giacomo dealt with a number of these points, and these are currently under consideration as it looks at the review of the RED, the emission trading system, and also the implications for the biodiversity directive. However, this debate has become highly polarized, as many have noticed. Subsidies on this scale generate strong resistance to change and strong lobbying efforts, and the science has got very much mixed up in this because of the complex range of individual cases, such as the two examples I already mentioned. It is thus all too easy to choose a case to support your own interests. Inconvenient studies can easily be ignored or outweighed by alternative studies with different assumptions or boundary conditions, so that policymakers quite understandably see the science as rather confusing. In the first paragraph here, I just listed a few titles of studies which discuss the downside in terms of loss of carbon stock and that make the whole supply chain and use of biomass marginal, if any, benefit to climate. On the other hand, the second paragraph is an argument you often hear that a holistic cross-disciplinary work, including considering net effects on forest management and other socio-economic factors, needs to be considered, which again adds to levels of complexity and increasing difficulty of validating any conclusions. So policymakers remain rather confused in many cases about the science. This kind of, there's no time actually to go into the public disagreement that we at ESAC have had with IEA Bioenergy over this, but there's a number of papers I've just listed here. But as part of that, we did have a very useful dialogue that allowed the scientists involved to agree on many of the basic aspects, but the policy implications still differ substantially due to approaching the common science from rather different perspectives. The debate is, however, very useful in identifying what we see as the key policy questions. We need to remind ourselves that the purpose of renewable energy is to mitigate climate change, which must mean reducing greenhouse gas emissions as fast as possible. That means that renewable in the case of biomass, which is not low carbon, needs to be considered in a timescale and compared with the times that is credible for avoiding Paris Agreement overshoot. The burden of proof, in our view, therefore needs to start shifting to the receiver of such subsidies to a more of a concept of payment by results. And that is where we remain as the debate gets even more polarized in countries such as the Netherlands, and I understand it is also warming up here in Sweden. So this story is really an example of how difficult it is to get policies to deliver the original objectives, how the simple approach to labeling bioenergy as renewable has failed to realize the carbon reduction potential of forest biomass. It has encouraged the release of the stored carbon into the atmosphere without requiring any quantitative analysis of the net carbon benefits by the receiver of subsidies. The incentives provided have not been matched by incentives to enhance carbon stock, although that is now starting to be remedied by the changes in the LULUCF criteria that we've heard. Also, the subsidies have generated special interests whose viability is entirely dependent on continuing the subsidies. So an alternative strategy in the case of priorities shifting as they have with biodiversity up the agenda is that first society needs to update the priorities and boundaries within which the stakeholders operate. Considering the wide range of ecosystem services that can be offered by forests, the historical precedent of indigenous use that has been sustainable for generations, along with the valuable economic benefits that can be obtained, it is clear that setting priorities on how to use this common resource is for the whole of society to discuss, as I'm glad to note that many speakers up to now have recognized. An additional complication is that while forests are justifiably a national resource for national political systems to decide, in the case of carbon, this has global dimensions, adding to the layer of complexity. Well, we have seen in this symposium's presentations how complex can be the science, raising even more challenges for policymakers. But scientists need to keep contributing to key issues such as payback periods, full life cycle assessment, measuring carbon stock, defining objective means of deciding forest reference levels, and implications of the many threats to forests we heard about yesterday, and as our opening speaker yesterday emphasized, must continue to do so transparently and with an independent and open mind. And on that positive note, I conclude my talk. Thank you.
Thank you, Mike. I don't know if, thank you for that comprehensive presentation. Is Göran still here? Or has he left?
No, Anders, I'm here. I'm a bit nervous since I will speak at 12.
Yeah, well, we have plenty of time. It's 9 minutes.
Yeah, I stay.
Yeah, okay.
Sure.
Well, here we have had 4 presentations who come to very, very different conclusions. And I don't really know how to manage the question and answer period. But let me start by asking Sampo the following. I mean, you imply that it's better basically to let the tree stand because the overall calculation you did was that there is a negative effect on carbon removals if we start to harvest more. But how do you take into effect the fact that trees at a certain age stop absorbing, or at least absorb much less carbon, whereas young trees absorb a lot of carbon? You didn't touch upon that. Could you please comment on that?
Yes, thank you. Can you hear me?
Yeah.
Okay, so first of all, many of those scenario studies are carried out in a way that the baseline scenario represents the current harvest rates, and then we consider that what if we increase the harvest rate. So that's basically something which makes our forests even younger. But there also are studies which consider that what if we reduce the harvest rates, in which case the forest age becomes older. That's a good question, that how well those forest simulators actually are parameterized and how well they can take into account that what happens when the forest age becomes older than the typical final felling age or something like that. I know that these things has been considered and the natural mortality has been increased into those models in order to take into account that the mortality increase in such a case. But basically the question is not about how much forests actually sequester carbon annually. The sequestration can be 0, but still the forest carbon stock can be significantly higher in some case in which we harvest less compared to where we harvest more. So the key point is actually that what is the difference between those forest carbon stocks between different scenarios.
Okay, thanks a lot. We'll come back to that in the afternoon, I think. I would like to ask Göran and maybe Giacomo to respond to Mike Norton's plea for organizing or arranging policy measures and policy incentives so as to favor short payback times. Göran, what is your take on that?
Yeah, I mean, I think Giacomo can maybe answer from kind of the practical perspective of challenges for policy to do that due to the difficulties here, because it's such a complex system. I think you saw that my entry point was a bit different. I look at this from this perspective of transition of systems. So it's a rather different perspective. I think I would like also to re-emphasize the difference between fossil carbon and biogenic carbon and how they actually differ in the sense that as long as we use the fossil fuels, we do insert more fossil carbon into this very interlinked system of the atmosphere and the biosphere. And I think it's also it's kind of a strategic question. We have talked about that many times, I think, Sampo, that I mean, it's a question. Now I don't make a statement. I think a difficult question is is it wise to transfer fossil carbon into the biosphere via the atmosphere? Because that is very much what you accomplish if you go for kind of a forest, leaving forests as carbon stores instead of prioritizing production for substitution. And I think that is a very difficult, it's almost a philosophical question. And it's a question also that is intergenerational, like what do we pass over to the coming generations if we have sought that as a solution? I think the answer to that is very dependent on how we do this. If for instance, we have as a priority to protect biodiversity and vital ecosystem services, and as a consequence of that, we harvest less and we sequester more carbon. That's one thing. Then we pass over something positive, very likely to coming generations. But if we have carbon sequestration as kind of a prime objective and it really shapes the strategies, I'm not so certain that coming generations will be so happy to use to be able to having to manage that biospheric carbon store. Mm. So I know I go aside the point now that you asked. I think Giacomo can answer the more technical issues here, but I think this is, for me, this is a very difficult consideration, and I'm not making any statements, but it's just something I really would be happy if we could discuss more.
Yeah. Great. And before I give the floor to Giacomo, I interpret this discussion very much a consequence of the Paris targets, and that we have a very short time period to really cut emissions significantly. But Giacomo.
So if I understand well the question, essentially you say, or Mike says, the climate problem is so urgent that we should design policy to maximize short-term climate benefits. So of course, I totally see the point. I think that what we heard from Sampo is a nice analysis of this kind of say integrating all the mitigation potential forest. Of course, this should go even beyond what Sampo shows, and having consideration, thinking even more in a system perspective, looking not only at the mitigation part, but also the adaptation needs, the resilience needs, because forests in Europe are getting older and more vulnerable to the impact of climate change. And all this has to be put together by politicians. I think scientists, we can also only try to be honest brokers of the available evidence, and putting all these together. So summing all the various mitigation potential, like Sampo said, taking into account adaptation needs, resilience needs, because if we need a healthy forest, it needs to be a resilient forest. We need to take care of this forest. So my answer is that there is no solution that fits all. There are a lot of local different conditions and local different solutions. Of course, what has been said, that climate problem is so urgent that we need a short-term solution, is something which has a great weight in the discussion, but there are also other aspects, including also social, economic aspects.
One question in the chat that I find interesting or challenging. Thank you, Göran. I understand you have to leave. Thank you very much for your contribution. One question in the chat was, are we too supply oriented? Why don't we discuss, when we discuss substitution, also the possibility for mankind, for human beings, to reduce their consumption and thereby indirectly exert less pressure on all kinds of resources? Why do we take for a given that everything just has to expand and grow and grow? What would be your comments, Mike?
Well, first of all, can I just add a comment to the previous question? And it's not just an issue of the forest resource, it's also an issue of public expenditure resource. And the question that drives us to some extent is that 6.5 billion a year being efficiently used for its stated public purpose of mitigating climate change? And the question then becomes, could you achieve a much more effective delivery of reducing CO2 emissions if that 6.5 billion were allocated to other areas, whether that's wind, solar, or tide? So it does get you into a broader system, which I think motivates you for greater transparency in how you use public funds. But moving to your second question, certainly, I mean, we have to limit our comment to what we were asked to comment about. But clearly, all the strategies on future scenarios for emission reductions have to start moving away from just tinkering with business as usual to a much more concept of transformational change. And I know, Anders, you're very active in this, and we worked with you earlier this year in a report on that. And of course, that has to deal with some of these underlying assumptions. We cannot continue growing either in population or in GDP per capita. We have to start thinking of different ways of measuring our success as humanity and working within planetary boundaries. But that's a much broader question than we could put into a 15-minute presentation on boreal forests.
But it seems to me that all three of you, because Göran has left now, you indicate that the incentives in the economy with regard to the use of biomass, and in particular with regard to use of bioenergy, leaves a lot to be desired, that we could develop the incentive structure further so as to make as efficient use as possible of bioenergy when it's being used, and to try to steer substitution more towards long-lived products, etc. Do you have any suggestions on how that could happen?
Well, that was the outcome of a special analysis by the Dutch, what is it, the Socio-Economic Council or something, where they really underlined the importance of thinking in terms of maximizing the use of biological resources, the so-called bioeconomy. And towards that event, they saw the priority in trying to steer it towards areas of industry which cannot be easily substituted, chemical industry and materials. And therefore, on that ranking, they saw use in bioenergy as the least beneficial from the overall framework in terms of the use of the limited resource. So, I mean, that approach has been taken in other countries, and I'm sure it's been taken in Sweden as well. And it must lead you to find some means of measuring the priorities and assessing the relative benefits of different applications of what is inevitably a limited biological resource.
But it's very much a European Union issue. Giacomo, what would your response be?
Yes, I would say, as I tried to explain before, the current LULUCF regulation, in my view, already includes a quite strong incentive to make a good use of biological resources, because essentially it says, look, you can harvest more than what you did in the past, even take into account age structure. But be careful, because unless you manage somehow to increment even more, or you manage to use that wood in a way that replace a significant amount of fossil fuel in other sectors, if not, you will incur in debt in other sectors. So I do think there is already an incentive that could, of course, be improved. In a few months, we'll have a new updated version of the RED 2, but also of LULUCF regulation. And happy to discuss them again once we have them out. The incentive is there. It's up to the country to balance the existing incentive, which is which has to be combined with a system perspective, which takes into account other aspects, which are very much local specific.
And thank you. And Sampo, you will get the last intervention now. You have anything to say on this? You have to unmute.
Okay, can you hear me now?
Yeah.
Sorry, yes, double muted. Okay, from climate perspective, I think it's quite difficult to say that whether that should be harvest more or less. Even if my results were quite pessimistic from the point of view of that if we increase harvest rates, because I think like Göran has told, it also depends quite much that how successful we are in climate change mitigation in the other areas, and how wise it's really, if the alternative is the continue of using fossil-based materials, how wise is that? So from my perspective, what is required is appropriate policy in which we account emissions and we account the removals, and then we can let the market decide. If we could create that kind of framework, it then creates us incentives, and it's taken into account. So if from market perspective, it's then wise to increase the use of biomass, then it's taken into account, and we are then inevitably acknowledging that, okay, there are trade-offs between increasing the sequestration and substitution. We take it into account, and we have to do some kind of other measures to compensate those harmful effects, if I say so. But from other perspectives, like biodiversity and things like that, I think it's much I don't know if it's easier, but perhaps more necessary to create some kind of boundaries and limitations. But from climate perspective, it's more difficult, because the issue is dynamical, and it depends on how successful we are.
Thanks a lot. We could have continued this discussion for quite some time, and I'm sorry we had a little bit of overdraft. I'll hand over to Lars.
Yes, thank you, Anders. Well, there was some overdraft of timing, but such a very lively discussion on a slightly controversial topic. I think it was well spent time. But of course, we need some lunch, and we should try to be back at 1300 hours sharp Central European time. So see you then. Welcome back, everyone. We are now into a session with the wording weighing different forest management systems from the perspectives of climate, ecology, and societal benefits. And the moderator for this session will be Professor Anders Lindroth, Lund University, the Department of Physical Geography and Ecosystem Science. So please, Anders.
Thank you. We have three speakers this afternoon. First one is Professor Timo Pukkola from University of Eastern Finland. Timo has been studying multifunctionality of forest using modeling and simulations, and here we talk on measuring the total benefit of different silvicultural systems. Then we have Professor Rolf Björheden from Skogforsk. Skogforsk is the main Swedish research institute for forestry. And Rolf has experience and expertise with many different aspects on forest operations. He will talk on adding climate goals to boreal silviculture. Is rotation forestry up to the challenge? And then we have Dr. Juliana Sanchi from Lund University. And Juliana is using multidisciplinary approaches to study climate, geoscience, ecosystem services in forests and more. And she will talk about forest multifunctionality hand in glove with forest management diversity. So I'm very much looking forward to hear all these talks. So please, Timo, the floor is yours. We can't hear you.
Yes.
No, now we hear you, okay.
Yes, I need to get, I think now the mode is correct.
Yes.
Okay, so I will talk about the total benefit of different silvicultural systems, which I am trying to measure at the moment. But first, we of course need to define what is the total benefit. And if we look at the textbooks definitions for social benefits, we can read that social benefit is equal to private benefit plus externalities. And if the forest landowner aims at timber benefits or timber production, then we can define social benefit as the sum of timber benefits plus externalities of timber production. This means that timber production or economic benefits to landowner, they are a part of the social benefits of forest management. And if we think that ecological effects of timber production are externalities, they also are a part of the social benefit of forestry. So we come to a definition which says that total benefit is equal to social benefit. And this is what this is how I have understood the concept in this study, of which I'm going to talk, and also in this presentation. I have divided the social benefits of forests into 4 categories instead of the ordinary 3 categories. And social benefit is not any subcategory in this grouping, but it includes everything. So I have divided the benefits of forestry into economic, ecological, cultural, and regulation benefits. There are 4 subcategories, and in this study of which I will talk now, there is a 5th criterion for measuring the performance of forest management, and it is resilience. And these different benefits, they have been analyzed in several papers, and one is by Kappen et al. It is a study or report which tries to estimate how valuable are the different dimensions of forestry. And in this review, the regulation benefits of forestry, they explain or account for most of the value of the forests of the world, from 65 to 90% even. And the economic use of forests accounts only a small part of the total benefits of forests. and the obvious reason for this high share of the regulation effects is the value of forests in carbon sequestration. But drinking water, of course, is also very important, and all these effects which are listed in this slide. And then we can have a look at the preferences of people, in this case, Finnish people. These are results from a very recent survey. And according to this survey, only 20% of people have a positive attitude towards clear felling. And 80% of Finns think that timber production is not the most important ecosystem service of Finnish forests. And 2/3 think that protection is among the 3 most important ecosystem services. And if we ask young people, they think that protection is many times more important than timber production. And less than 10% of young Finns thinks that timber production is the most important ecosystem service. And now we may ask that does forest management correspond to the preferences of current and future Finnish people? And the answer is quite obvious. It does not correspond to the preferences of Finnish people. Here is an example of a young spruce plantation in northern Finland. And we can have a look or think of the ecosystem services of this forest. There is no timber production in this forest. It's practically zero for 30 years. Carbon sequestration is negative. This is releasing at the moment more carbon than it is sequestrating it. Recreation benefit are practically zero for a long time. It's not let's say, lucrative for nature tourism, for example. And the yield of large dead wood, it is interrupted for at least 300 years in this forest. First, the trees, they need to become large, which takes 150 years, and then they need to die. It takes 300 years, and then they need to reach a certain decomposition class to become a suitable environment for some fungi or insects. And this process in this forest might take 300, 350 years. And the silvicultural systems which I am comparing, they include continuous cover forestry. And this concept has been misunderstood quite much, at least in Finland and maybe also in Sweden. Many foresters think that continuous cover forestry is equal to uneven age management. And that is not true. In German language, there is a different name for continuous cover forestry. It is called Dauerwald, and uneven age forestry is called Plenterwald. Continuous cover forestry is any management in which there is no clear felling. The structure of the forest is not so important. The idea of the whole concept is that there should be no interruption in the production of ecosystem services. That is the main goal of continuous cover forestry, according to the original developers. And all cutting methods except clear felling can be used in continuous cover forestry. And it begins when clear felling stops. There is no transformation period. There is no need to have any period to transform from even age management to continuous cover management. And it can be started immediately in all forests, maybe except clear felling site. Here is an example. This is my forest of thinning from below in continuous cover forestry. This is continuous cover forestry because this will be managed without clear felling. Thinning from below. Another stand from my forest, and this is even-sized forest, but this is also continuous cover forest because there will be no clear felling in this forest. This has been heavily thinned from above recently, and there is already regeneration coming in the openings, extraction roads, for example. Another stand representing continuous cover forestry from the same forest. Heavy, high thinning to make growing space for the younger and smaller trees and to promote natural regeneration. Another forest, spruce in this time after a very heavy, high thinning, and this is timber harvested from that stand which was in the previous slide. The income is very high because most of the removal is sawlog and the share of pulpwood is quite low. Another forest, last summer in fact, very heavy thinning, which means that the economic return is high, around 6,000 euros per hectare was harvested. And in my opinion, there are no big interruptions in many ecosystem services in this forest. It looks good, in my opinion, and it is productive and the quality of the remaining trees is very good. It is producing good quality sawlog. But continuous cover forestry does not guarantee that there will be deadwood in the forest or very large trees. You need to take care of that by leaving retention trees also in continuous cover forestry. This is a group of retention trees which I have left in my forest. Okay, and then we will go to the study in which I'm trying to measure the overall performance or social performance or responsibility or acceptability of different silvicultural systems. There are two case study forests in this study, one representing northern boreal forest and the other is southern boreal forest. Both are about 500 hectares. And the time horizon is 100 years, and the silvicultural systems are listed here. There is even-aged conifer-oriented management, even-aged mixed and oriented management, continuous cover forestry, and then so-called freestyle or any-aged management. And in all cases, the net present value is maximized with 1%, 2%, or 4% discount rate. The private benefit of the landowner is maximized in all cases. And there are 5 criteria which are used to measure the performance: economic, customary uses, regulative function or benefit of the forest, biodiversity, and resilience was taken as the 5th. And each of these criterion was further measured using 3 indicators. For example, economic benefit was described by using net present value, sawlog removal, pulpwood removal. Biodiversity was measured based on the limiting factors in Finnish forests, which are deadwood volume, volume of aspen, and volume of other broadleaf tree species. Resilience, which was the 5th criterion, was measured using tree species diversity, size diversity, and then between stand height variation of the forest. The last indicator is based on the fact that the most wind throws occur at stand edges when the height difference between 2 adjoining stands is high. Those are vulnerable places for wind throws, and they are also the probable starting places of bark beetle outbreaks. And these 15 indices, they were calculated for different silvicultural systems, and then from these indicator values, I calculated overall performance index using different formulas. For example, utility function, a formula which is based on compromise programming, so-called border count, and 2 other methods. And here is one example of the results. The columns are different ways to calculate the total performance score from the indicator values. For example, this SMA means stochastic multi-attribute acceptability analysis. And the lines are different silvicultural systems, and the number here, it shows the discount rate, which was used to maximize net present value. And the first obvious result is that continuous cover forestry does not perform, even-aged conifer-oriented forestry does not perform well, especially if the discount rate is high. It's usually at the bottom. Another result is that continuous cover forestry is good in most rankings. especially if the discount rate is low. And then there is a no-cutting alternative, and it is sometimes the best and sometimes the worst or among the worst. It is very sensitive to the method which is used to compile the overall performance measure. And then a few slides about the values of different indicators. First, net present value. CON is conifer-oriented even age management with 4% discount rate, and CCF is continuous cover forestry when net present value is maximized using a 4% discount rate. South is Southern Boreal forest, North is Northern Boreal forest. And you can see that in this calculation, the profitability of forestry to landowner is better in continuous cover forestry. Then is timber production, timber supply. It is a benefit to the forest industry and to whole society simultaneously. And in this analysis, the timber production in 100 years is better in continuous cover forestry than in even-aged conifer-oriented forestry. And the difference is mainly explained by the higher production or higher supply of sawlogs in continuous cover forestry.
3 minutes, Timo.
Yes, berries and mushrooms, they are usually, they are slightly, the yields, predicted yields are slightly higher in continuous cover forestry. Scenic beauty index, slightly higher in continuous cover forestry. Carbon balance, it is mainly due to the so-called substitution effect of forest products, because the carbon stock of forest biomass and forest soil does not increase. And also in this comparison, continuous cover forestry is slightly better than even-aged forestry. Then are these indices which are describing resilience. Both the Shannon index, which describes species diversity, and Gini index, which describes size diversity, are higher in continuous cover forestry. And the height variation between different stands is lower in continuous cover forestry, which is good. And then is deadwood and the broadleaf volume. Deadwood is always very low in managed forest, even if it is continuous cover forestry. But there is more broadleaf and aspen, which also contribute to biodiversity, and they are slightly higher in continuous cover forestry. And the summary, if we want to rank the silvicultural system, is here: continuous cover management #1, and conifer-oriented even-age management #4, or the worst, and the other 2 silvicultural systems are in between. The effect of discount rate is such that if it is high, the overall performance of forestry or overall benefit of forestry will be low, and especially bad combination is a high discount rate combined with conifer-oriented even-aged management. Thank you.
Thank you very much, Timo. It was very, very interesting. We will come back with the questions when we have heard all the talks. Okay. Rolf, are you around somewhere? Yes, please, the floor is yours.
Okay, so now I'm also unmuted. I can't see my pointer right now. Okay, maybe it doesn't matter. I'll share my screen. I had some technical problems here, but I'll share my screen with you. And I think you can see it now.
Yeah, we see it.
Okay, so I'm going to talk about can we add climate goals to boreal silviculture? And the main question there is rotation forestry up to the challenge. And I'll start. My starting point is a small meta study that I did on the carbon flux and store in the Nordic-Baltic region. And this is dominated by rotation forestry. So I will talk mainly about what we know has happened in the last 100 years or so. It's based on this study, as I said, that was published by SNS about a year ago. And I have to acknowledge also the help that I got from experts in the included countries in doing so. So I'll compare this with the modeling approaches mainly for continuous cover forestry. And my focus will be on carbon cycling and greenhouse gases, but I will also look into economic, social, and ecological matters slightly. I agree with Mr. Rumokainen there that I think you can't just talk about climate benefits. You have forestry is so wide-spanning, as also Timo said recently. So first, a little bit about the Nordic-Baltic region. Not all of us are from this area. There are about 33 million inhabitants here. We constitute 5.5% of the European population, and I'm excluding Russia now in these figures. There are 73 million hectares of forest land in this area, and that is 35% of the forested area of Europe, so quite substantial. Looking at the Nordic-Baltic region as I have defined it, it consists of Sweden, Finland, Norway, Latvia, Estonia, Latvia, and Lithuania and Denmark. Of these three countries, Sweden, Finland, and Norway, account for some 90% of the total area, and also have very good data on their forestry, not only on the standing inventory and growth, but also on common forestry practices. So in some cases when I've had not so good data, it's mainly from Estonia and Lithuania actually, but I think that it doesn't mean so much for the results. Okay, so I'm starting with a carbon balance for the Nordic-Baltic forest then. And first I look at the carbon pool, and I define that as the sum of the standing inventory presented as carbon in stored in tree biomass. And I look at the store of soil organic carbon in the forest soils. Then I move on to looking at the dynamics of carbon cycling. So I look at the inventory dynamics, the net effect of growth, felling, and other losses. I look at the impact of forestry on soil organic carbon, which is a very big matter for discussion. And then I also included the study of the carbon dioxide emissions from forest operations, transports, and road building, road maintenance, and so on. All the mechanized work that goes into forestry in the Nordic countries. And I also added a small analysis of the substitution effect of harvested wood products, which I think is an important part. It's an argument that you often hear from the pro side of forestry and rotation forestry. So first we look at the carbon pool in the standing inventory then. The total inventory in the region is almost 9 billion cubic meters stem volume over bark. Of this, around 6.2% are dead trees still standing. This is actually an increase of 209% compared to the historical national forest inventories of the different countries, which is quite impressive, I think. And the inventory today in the standing timber corresponds to 13.4 billion megatons of carbon dioxide, and 85% of this is on working forest land. WFL, that means working forest land. So it is forest areas that are used for forestry. It's not nature reserves and national parks and so on. This is 60 times the current regional territorial emissions as carbon dioxide. And if we do the maths here, we can see that since it has increased by to 200% from the 1920s when the first NFIs were made, it means that in that period we have accumulated 30 times the current regional territorial emissions in this area. Now we move on to the carbon pool in forest soils. It's very, very variable, the level of soil organic carbon. You can see in the north of Sweden and Finland and Norway, maybe 30 to 40 tons per hectare. On the west coast of Norway, quite a lot higher, 140 to 160. In Denmark and also in the Baltic states, between 160 and 180 are quite normal. And in Sweden and Finland, between 60 up to 90 in the south of Sweden. So it's very variable. And the regional average that I found was 92 tons per hectare. The total soil organic carbon pool was 7 billion tons of carbon. That corresponds to 25.7 billion tons of carbon dioxide. So it's quite a big pool. If we combine the pools in the standing inventory and the soils, it equals 175 years of current territorial carbon dioxide emissions. So it's a lot of carbon out there. Okay, then we move on to the current carbon flux of the Nordic Baltic forest sector. And I only present this as 1 million tons of carbon dioxide per year. The annual growth in the region corresponds to 454 million tons of carbon dioxide. We harvest every year 315 million tons of carbon dioxide, of which almost 170 million tons are delivered to as harvested wood products. There is also quite a considerable amount of other annual loss due to insects, storm felling and so on. Possibly a double counting of some of these volumes, but it's quite a lot of wood that is lost, not due to directed felling, but to other calamities. The net annual inventory change then that was recorded was around 76 million tons every year. If we look at the soil organic carbon accumulation, it seems to be in the order of, these are rather insecure, but in the order of 2 million tons per year. And we probably lose about a little more than 500,000 tons every year due to the losses during the clear felling phase, where I counted between 20 and 30 years before we have recovered and are back on the same soil organic carbon level as we were before harvesting. And the emissions from forest operations then and transports, 2.5 million tons of carbon dioxide every year. So the net annual mitigation currently in the sector is almost 80 million tons of carbon dioxide. The substitution effects then, I said that I was going to mention them also, of harvested wood products. And I'm using the EFI study that was also used by Marko Rumokainen yesterday. So I'm using a substitution factor of 1.2, and that means that these products up here, they eventually make the fossil carbon load or carbon dioxide load 200 million tons smaller every year globally. Not all this wood is consumed in the region, of course. Okay, so now over to the comparison with continuous cover forestry, and I had to make some assumptions. So I said that let's say that we don't count on any transition period, but we start managing spruce stands by selective harvesting completely, and all other forests we manage as in a shelter wood regime. This will give reduced forest growth according to what we believe in Sweden at least, or at least that's Skogforsk, by 19%. It will minimize the possible harvest of logging residues. The proportion of sawlogs will be higher and the proportion of pulpwood will be lower. And the harvesting cost will increase, felling by 35% and forwarding by 40%. Road maintenance and transport costs will increase by 20%. And these 2 points is because the wood is less concentrated, so you have to drive longer, and it's also a more difficult harvesting situation for the machine operators. And if you're going to harvest big trees, and some of the trees will be big, you need a big machine. Fossil emissions from the operations, they increase by around 20%, according to this study. There are also some very positive things about continuous cover forestry, a positive recreational value, but we will also see a deficit of pioneer tree species, especially broadleaves like birch and aspen in parts of the landscape, namely the spruce-dominated areas. There we will see that they will decrease. It's positive for all species that are sensitive to disturbances, of course, because the disturbance is less, and positive for reindeer husbandry, berries and mushrooms and small game, but negative for deer. So let's now compare rotation forestry and continuous cover forestry for the Nordic Baltic sector as million tons of carbon dioxide per year. You can see here that the annual growth is lower. And of course, then the annual harvesting will also be lower if we have the same ratio of harvesting as we have today. The amount of harvested wood products will decrease even more just because we can't harvest as much forest residues for energy as we can do in rotation forestry. So the net annual inventory change then will be down by some 15 million, corresponding to 15 million tons of carbon dioxide. And the net annual mitigation will also be down by a similar number. Substitution effects will go down quite dramatically with almost 50 million tons. So the net effect you see here, and I want to highlight that the strongest negative aspect of turning into complete continuous cover forestry would be that we have less harvested wood products and we will get a much smaller substitution effect. But it is also negative in the other cases. So I think after studying this, that selective and shelter wood regimes, they add really interesting alternatives to the forestry toolbox. I think that they should be used. but I don't think that we should motivate them by for greenhouse gas mitigation purposes. Maybe 5 to 15% of the working forest is suitable for CCF in Sweden, according to my opinion. I think that it would mean a lot for the PR value of forestry if we used more of CCF methods, for instance, in the urban fringe for recreational value as a sort of service to the people living in the urban areas. I think that continuity forests in, for instance, natural fire refuges would be very nice also, and it would strengthen the populations of some species that are sensitive to disturbances. I think that we need to balance the needs of forestry and climate goals with considerations for landscape aesthetics, reindeer husbandry, production of berries and mushrooms, biodiversity, and game management. So it's not just one goal. We have to be able to think more than one, have more than one thought in our head at the time. And that is what I'm trying to say there. I won't go on about it. Okay, so can we improve the climate benefits of the Nordic Baltic forests in a rotation forestry, which I think will be dominating what's in the future? Is for rotation forestry up to the challenge? I think we could utilize, this is a very simple solution, utilize more of the felled biomass. If we take out only 25% of the residues that we leave on the felling area today, that would mean an added benefit of 30 million tons of carbon dioxide. Purposeful sourcing of feedstock, I think, to maximize the substitution effects. But this is, of course, something that the customers, the people who are buying the goods from the forest industry, they must demand better products. But I think that there is some important work going on there, that we will see that substitution effects will eventually be higher.
3 minutes, Rolf.
3 minutes?
Yep.
Yeah, okay. Use and reuse, cascading increases the carbon retention time. And also, I think we could increase primary production. We could work on larger areas. We can have extended, we should look at the rotation period. There is a tendency today that we are cutting down the stands a little bit too early, and that is very, very risky from a carbon retention and carbon cycling point of view. I think we should look at improved silviculture when it comes to tree species, tree breeding, and also improved resolution of silviculture could do a lot for us. I'm going to very quickly just go through. This is what it looks like. In principle, the biogene carbon just cycles around. But if we add people to the carbon cycle, we will find that if we use carbon, we actually create a platform where we can, where the carbon can get off the cycle, spend some time with us, and then get back into the cycle again. And as long as we don't exceed growth with the harvesting, the content of CO2 is stable. This is really what is important, and this is now I'm going to my final picture. Forest products decreases the need for fossil carbon compounds, and this means that the addition of carbon to the biosphere is reduced. This is what is causing the climate crisis. It's not forestry, it's the over-intensive use of fossil carbon compounds. So my conclusions then, the forests are important for the region's climate work. It stores carbon, captures atmospheric carbon dioxide, and the products add huge climate benefits if we produce sensible things. The storage sink ratio should be optimized for maximized benefits. And this is a long-term mission. It's not something that we can change every 5-10 years. We have to decide what we want to do now. Active forestry is needed for sustainable climate benefits. And I don't think, finally, that boreal forestry can save the global climate, but maybe we can contribute to the solution. I'm sorry for taking a few minutes extra there. Thank you for your attention.
Thank you very much, Rolf. You were perfectly on time, no problem.
Ah.
So we have now two very different views on this, and I'm sure it will be part of the discussion later on. So maybe we'll hear now a third alternative. So please, Juliana.
Yes. Do you see the presentation?
Yep.
Yes. So
sorry, Juliana, it's in the, we see your next slide. You should.
All right. So wait a second.
Display setting, yeah.
Display settings. This one maybe? No.
Yes.
Yes, yes.
I think so.
Yes.
Try that.
Right. So today I'm going to present a little bit some reflections, results and reflection on the relationship between forest multifunctionality and forest management. Yes, I would like to take you for a virtual tour. Since it's Friday afternoon, everybody has been listening to many presentations, a lot have been said. We don't have the opportunity to go in the field, but this is the forest behind my house. And when I was preparing the presentation, I thought this is really a summary. It's a small forest, but it's a summary of a lot of things that have been discussed in the past days on forest multifunctionality and the challenges that are in front of us. So there is a river going through this, the forest, which is a source of fresh water for the community. It's a small village in Småland, so center Sweden. And we have a pine-dominated forest on this side and spruce-dominated forest owned by a private forest owner on this side. This is communal area. Then we have between the river and the pink line, it became a natural reserve because as you see, this is quite a sparse forest, and it was affected by Gudrun, the big storm in 2005. So they decided to see what would happen if we would leave the forest unmanaged. So this is unmanaged now. And these have become, of course, a source of recreation. In the past year, we have been seeing increasing amount of people going in this forest because of the COVID situation, especially older people. Here are like barbecue places that I use with my families. This one is nicer because it's closer to the river. So these, and here also we had a fire caused by recreation, as was said yesterday. We can see actually natural regeneration here happening with the succession of birch and pine. And then another thing that is present is here is a bioenergy plant. So everything is there in a very small area. And here what we can see, sometimes I wonder on the efficiency of these bioenergy plants. So there are being discussion this morning about what we should do, increase the extraction of wood to produce more bioenergy, or if we should maybe think about increasing efficiency. One thing I can see here is sometimes when it's heavily raining, there is no protection of the chips that you see in this corner, increasing a lot of moisture of these chips, and as a consequence, decreasing a lot the efficiency of this bioenergy plant. So there are like challenges, so a lot of services provided by forest, but a lot of challenges in front of us, how we should manage this forest in the best way to conserve, but even enhance these services. Because if we think about it, there are basically two types of management in this area. So it's conserved, non-touched, and then rotation forestry with different ages. And if we think about species, it's basically two dominating species, pine and spruce. We saw yesterday some maps from Boreal forest in Russia, how diverse Boreal forest can be, how many species we can have. So is this the best way to manage forests, to optimize or maximize multifunctionality? And why are we thinking about forest management is because we actually, if we think about it, it's the disturbance or the type of intervention that happens most frequently in forestry. So when we look at the amount of wood that is affected by or harvested in Sweden, we see that it's quite a lot, and it's actually increasing over time, as many said today. When we look at this peak here, there are different kind of estimates due to different sources. So this is based on statistics, and this is based on plots. Fixed plots of the National Forest Inventory. But here, this peak here is Gudrun again, so the big storm that happened in 2005. But when we look at the effect, still, the amount of fellings, the amount of wood that is affected by forestry is much higher than even the biggest disturbance that we had in the past years and past decades in Sweden. So I'm going to present the results from a study I did with an economist, trying to evaluate these different ecosystem services simultaneously. So taking into account not only harvest and carbon benefits, but also including other type of ecosystem services. Through a modeling exercise and connecting it to economic evaluation. This was just for me a sort of curiosity to see, by using the same unit of measure, what would be the results. And there are a lot of discussion about economic evaluation, if we should be doing it or not. I will not go into this because I'm not an economist. I think this is a discussion that should be carried on by economists. And if there are better tools, they should be brought up. So what we did was to take a forest in southern Sweden, a spruce-dominated forest, 70-year rotation period, and try to model what the effect of different management options would have on this forest. So we had business as usual, rotation forestry with stem harvesting only, then whole tree harvesting, extracting residues, whole tree harvesting, and a shorter rotation period, so even more intensified, and then continuous cover forestry that we modeled as basically continuous thinning over time every 15 years. So there are assumptions there on what continuous cover forestry is, and we saw previously from Professor Pihl how different continuous cover forestry can be. Mm-hmm. So when we used models, because when we look at the complexity of this issue of considering simultaneously the effect on different ecosystem services, including climate change effects. So it's very difficult to have experimental areas that can answer all the questions, especially if we want to upscale it. So we used, in this case, a dynamic ecosystem model because it can include also climate change effects. But any model could be used for this purpose. What you do is to compare the alternative management scenario with the business as usual scenario for different ecosystem services and see the difference over time. I have to say that here we didn't look at one single actor, but we looked at the full rotation system. So the results are the average on a 70-year hectare area which is rotated. Each year, 1 hectare is cut. So it represents all the ages in the rotation. And and then what we wanted to do is, since these different physical indicators have different units, we wanted to convert it to a common unit that is money, that are more easy to understand than kilograms of nitrogen leached from per hectare. So then we try to give an economic evaluation of the changes. So it's not an evaluation on the service itself. So it's not a picture of the service, but evaluation of the changes when you compare over time, when you consider different management options. And here is a list of how we did it. There are different ways of doing it. I know this would probably bring some critiques on the economic metrics that we have been using, or methods, but this is the best that we tried in any case. There are different ways of doing it. So biodiversity was willingness to pay, and retention we used approach using agriculture. So the reduced, so the benefits, marginal benefits of improving water quality in the Baltic Sea. Forest carbon, it was, we used a carbon tax rate, and wood production was based on timber revenues. So the results are that the continuous cover forestry is slightly give a higher benefit if you look at 2100. So if you look at the increasing value over time, so it's the value changes over time. If we use a discount rate of 2%. And the things that came out are that the result is based on the fact that we have less harvesting on the carbon, so in the continuous cover forestry, but we have a higher accumulation in tree carbon. This is based on, is a result that comes out from the assumptions that we made, and these might shift from one or the other depending on how intensive your continuous cover forestry is. But if the, even if the forest grows less, then you would still have accumulation of tree, less extraction maybe, but accumulation in trees of carbon. And I was thankful to see from Professor Pihl that there start being data on that, because when we did this study, we had to do very big assumption on the continuous cover forestry because of lack of data, especially economical data. So how profitable it is, we had basically to apply costs and revenues for thinnings that we know that are not realistic. If we think about the type of timber that can come out of continuous cover forestry, so higher value timber. And if we think about the technological development, it is true that currently continuous cover forestry will probably rely on the same systems or same technologies as rotation forestry. But if it's expanded enough, it could be a very big opportunity for technological development with machineries that are less heavier than the ones that we are using now. And therefore maybe decrease the costs or the carbon emissions that we saw in the previous presentation. The other thing is that, and came out also from our study, and Professor Pihl already showed, is that that would decreases even in continuous cover forestry if we don't implement retention. And this was initially surprising for me, but it's actually, talking with the colleagues in Germany, it is a current discussion that we should leave retention also in continuous cover forestry to have that food there and therefore increase biodiversity. On the other hand, this is the only biodiversity indicator that we used, and we have to think about that there are continuous cover forestry also brings other species and also a different structure, so a structural difference that is beneficial for biodiversity. But then, so this is a study that was done on a sort of trial forest. But what happens when we look at the landscape? How much should we implement continuous cover forestry in a landscape? And here I have to say that excellent research comes from Finland, which is very, very impressive, which tries, so the group of researchers is trying to understand what is the optimal combination of different management practices. And it comes out that continuous cover forestry should actually be maybe the most dominant forest practice if we want to optimize multifunctionality. But this goes, so if we start here in this graph, they showed if we don't manage at all forest, so you have with no net present income, that is therefore no harvest extraction. So you would have to set aside all your area. But if you want to increase your net present income, you should progressively decrease the protected areas, so the set aside areas, to a percentage that is not very far away from what the current 5%, I think it's in Sweden, if we want a very high net present income. And this is replaced initially only by continuous cover forestry that are represented by the green, blue options. So they included many options of continuous cover forestry. And when we want to go to higher net present income, so higher wood extraction, then we should include also rotation forestry. But it comes up at a quite higher net present income level. And that is because actually, if you look at the multifunctionality curve, so we have initially continuous cover forestry increases up to 4, I think, was kilo euro per hectare. Then you would have increase of multifunctionality. But it starts decreasing later, and to reduce this decrease, we could introduce rotation forestry that would reduce this loss of multifunctionality. And here we go to a balance between what we want for forest. If we need more harvest, more harvest, then we need to include more practices. One short comment on the landscape, because often they say, but if we want to manage at the landscape, it will be difficult by putting together all the forest owners and decide to tell them what they have to do. But still, this group in Finland tried to do this analysis of different scales. And even at the small holding, large holding, the different combination of forestry practices would be actually the same. So there is a possibility to do it even at a property level. When we think about where to do it, an interesting concept comes from Canada. It's functional zoning. So they start by saying, we divide the area in 3 parts: a conservation zone, a wood production zone. So first we identify the areas to be conserved. Then we identify the areas where we want to have production, the highest productive area, forest in that area. And then all the rest we can manage with a less intensive management. That could be this selective harvesting. And this concept was born to reduce the impact of forestry on the natural structure. So if nature would act, how can we reproduce that in the best way? This concept has recently been developed to even think that we could have still these 3 zones, but then we could, at least each 3 zone, we could have identified forests or areas that would be more vulnerable to climate change and apply slightly different forest management practices to include, to make the forest even resilient in this structure. Another last thing is about the current, so what is the baseline? So if we want to change forest management, we have to understand what is the current forest management. And I'm working on a paper now that still I have to work out because I hear controversial kind of messages on that. So I've heard today several times that forests are cut too early sometimes, but I looked at more than 500 national forest inventory plots, and the average age is much higher than the age that I would have if I would apply the recommendations given on the type of the age when forest should be cut. And this came out because I was trying to model, validate my model, so the forest biomass that is in this plot. And I always got a lower value. My model, I could not get it right. And then I look at the age, and then it came out that by correcting the age of felling, so to be older than what is following these recommendations, then I would get the biomass right. So baselines are very important, and there's being, like mentioned, additionality. When we want to reach our objective, we should think about what is additional, and then we need to know what's the baseline. And here I conclude saying that I wish, so one of my wish is to move from an antithetical to holistic perspective. There are others that have mentioned a balance between all services. So we don't have to focus anymore. Should we conserve or should we store carbon? What, in my view, we should try to reach everything. So try to achieve everything. And a mixture of different management approaches is shown to be probably the most desirable option. Not all services might be maximized by the same forest management in different areas. So we might want to have this functional zoning where one of services is maximized. Landscape scale can be compatible with ownership scale. So this is very good news. Make it easier to implement it in the field. Well, and then we need to work all together. There is no way one researcher can, or a group of researchers can solve this issue. We need to work with social scientists, economists, to understand manager preference and motivation, market demands, European pressure, and land use changes. The other thing about climate change in the context of the conference is that more diverse will probably be more resilient. If you think about such uncertain future as we have in front of us, what do we want to do? Do we want to put our money all on the same horse, or do we want to diversify? I think I would like to diversify, even if I think about my bank account. So to take into account also extreme changes. Thank you very much.
Thank you very much, Juliana, and all other speakers as well. So we have now, I don't know, 5 minutes, a little bit more maybe, for a discussion. And I thought I can put the first question to Juliana. You used the 2% discount rate in your calculations. How would the result be if you had another discount rate like Timo's 4%, for instance?
We did that as a sensitivity analysis, and the results change radically. But that has to do with the fact that if we start thinking about future generation or we think about the revenues today. And that was the discussion that came up also in the bioenergy. So we have to think about what we want to do. And in my view, so there was a discussion about how forest management is not something that can be changed continuously. So we need to think that it's a very long-term thing. So a perspective that takes into account future generations should be there because it's actually how it works. So a high discount rate looks at the perspective of the forest manager today, but most of the forest managers, I would say, think about also to their grandchildren. Yes, so maybe when we think about shorter time, we should more think about technological development, as it was discussed this morning. Optimization of improve of efficiency. This is something that can have effects in the short term. But even if we change the management today, we will not see the effects in 2050.
Okay, thank you. Maybe some comments from our two other speakers. Rolf, do you want to start?
Yes, I can comment and say that I think that Juliana expressed it very well in her final statement there. That is something that I could sign on to. But did you have anything special in mind, Anders?
No, well, I thought maybe you want to comment also Timo's presentation, if you have.
Yes, we did quite a big literature study on continuous cover forestry methods, and we had some of those studies are more in line with Timo's, but we did some kind of average, and also we have some practical experiments. So that is why we ended up with 90% reduction in forest growth, which is of course very heavy. That doesn't mean that this is true. It means that this is what we found, and Timo has found something else. I'm not questioning that. I think that he has done his maths.
Okay, thank you. Timo, do you have some comment to the other speakers?
So my growths, they were based on growth models, and the growth models are based on trees measured in different structures.
Okay, so
and I took into account the tree breeding benefit for all planted trees. I improved the growth by 10%, and I also took into account the so-called harvest stress in continuous cover forestry after heightening. The growth prediction was decreased for 5 or 10% for the first 5-year period. And I think that there is no overestimation in my calculation, and I was not favoring continuous cover management. And I have also measured growths in my own continuous cover forest. And the trees are growing very well. Especially the relative value growth is very good.
I think that may very well be the case. We've seen similar cases that in some stands and in some conditions, CCF seems to be possible to combine with fairly high production, but it's a big variation. The variation and the uncertainty in CCF seems to be higher than with rotation forestry, according to what we saw.
Yes, and from silviculture we know that so-called co-dominant trees, they have the best thinning reaction. And in an optimal continuous cover forestry, you should try to leave all those trees to continue growing, because they react positively and they grow well. And especially the share of valuable assortments is increasing in those trees, middle-sized trees.
And it is, of course, a challenge to have a continuous supply of co-dominant trees to harvest.
Yeah.
We have a question here from the audience. They're saying that the continuous forestry produces timber more suited for construction material, less for pulp and energy. Shouldn't this be weighed in when calculating climate benefits, as the carbon ends up in more long-lived products? Is that something that you both have considered?
Yes, I have. All harvested trees was divided into different end products. And the whole lifespan of the end product was taken into account.
Okay.
But not the quality of the timber, only the shares of pulpwood and sawlog. It was taken into account. And each harvested piece of wood was divided into end products.
In the complete report by Sonesson et al., it is discussed in detail, but I think that using maybe a differentiated substitution factor, I didn't feel comfortable doing that. To be quite honest, I don't feel comfortable about the substitution factor at all. I think that we know too little about this, and the substitution factor is also a moving target. I mean, if we use a cardboard box instead of a metal box, maybe it's a very good thing. But if we reuse that metal box enough, that will probably be better. This is really a swampy area where we need to do a lot more research when it comes to substitution effects. Okay. So take my numbers on the substitution effect with a lot of salt.
That was actually another question, and now I think you have answered it. Let me see if we had some more question here. Beeping sound, no.
There is a question to me, at least, about the spruce, dominance of spruce.
Oh yeah, that's right.
Yes, so some growing sites, they are absolute pine sites, very poor sites, and some peatland forests. So the spruce taking dominance is not a problem. But in other cases, you can always try to slow down the spread of spruce, harvest more spruce than pine and birch. But if the stand converts to a spruce stand, you can make small openings to promote broadleaf regeneration. So instead of just harvesting, you can make small gaps. And if they are not too small, you will get birch regeneration. And of course, I'm not promoting continuous cover forestry, but I'm just optimizing the management. And if the spruce is a too big problem, you can always clear fell the stand. It's not a problem for me. So what I'm doing, I'm trying to optimize the management.
Okay.
And the consequence is something. I think that it would be a very much reduced use of clear felling if the management is really optimized. I agree with Juliana.
We have one question also about the possible differences in resilience between these two types of forest management systems. Maybe, Juliana, do you have some comment on that?
Well, I think that comes from other research that so if continuous cover forestry allows other species, and it's a situation where you have different levels of forest, so that it's not just one layer, it would be a more resilient forest. Then also discussion can be about the water and nutrient use. And that it was included in the model, but we didn't look at that in particular. I would say that actually by including different type of forest management, we will have a more resilient landscape. So because we don't know very well how it will be.
Okay, I think it looks like we have to finish now. Lars? Or... Okay, so thank you to all speakers again. It was very interesting to hear your different views on this topic, very hot topic. Thank you very much.
Yeah, thank you.
Yes, thank you very much. Yes, we will have a break now and we will reassemble in a little bit less than 10 minutes, so 14:25. Welcome back to the final panel discussion. Yes, hello everybody again. Well, we have some new participants here, I see. So everybody doesn't know who I am. I'm Lars Bergström and I'm the Vice President of the Royal Swedish Academy of Sciences. And I've been chairing this very interesting day that we've had. And of course, now we are looking forward to a very active and also exciting closing panel discussion. And again, the moderator will be Anders Wijkman, who I think most of you know, but please, Anders.
Thanks a lot, Lars. Welcome to our panelists. Is this functioning? Am I on?
I think you are on, yeah.
Okay.
Yes, we have to ask all the panelists to turn their camera on.
Okay, please turn your cameras on. Anders Lindroth, Kristina Yngve, Rebecca Lemoine, Jytte Guteland, Erik Eriksson, Julia, and Marco. Can we start?
Yes.
Well, welcome back. And a special welcome to the panelists. We have arranged it so that Julia Pongratz and Marko Rummukainen, who have been very active participants since yesterday morning, Marko also giving the introductory speech, and Julia one of the first lectures in the first session, to give some reflections on what they have heard and what they have concluded. We would then turn to Kristina Yngve, who is chair of the Agriculture and Environment Committee of the Swedish Parliament. We would turn to Rebecca Lemoine, who is a member of that same committee and also a member of the Swedish Parliament. We would hear from Jytte Guteland, who is a member of the European Parliament and has had a crucial role, and I believe still has this role, to be the rapporteur for the European Parliament on the so-called climate law that I believe is going to be voted finally in plenary in a couple of weeks' time. We are also going to hear from Erik Eriksson, who represents the Research Council Formas. Erik is head of the analytical department. Very welcome. Stefan Nyström, the deputy head of the Swedish EPA, could unfortunately not join us, but we have asked Anders Lindroth to fill the gap, so to say. And before I turn to Julia and Marco, let me just underline, first of all, that this has been a very, very rich conference, and we have touched upon a great number of issues. And I tried to make a list of challenging questions that either remain to be responded to or answered, or where we have had very diverse views. And that list compounds to some 20 issues. And of course, we will not be able to deal with all of them. But I believe that there are a few clusters of issues that we should try to comment on in particular. One is the whole question of multifunctionality and how to meet the demand of multifunctionality. And I would like to refer in particular to Timo's presentation about half an hour ago, where he indicated that the value of a forest is, of course, the value of timber and wood, but there are other values that, according to him, are much more important, like the regulation of the hydrocycle, carbon sinks, etc., resilience issues, recreation. So the whole multifunctionality issue and how to address it is one set of issues. Another one is, of course, how much biomass do we need? We had an interesting discussion this morning between Sten Nilsson and Thomas Lundmark, indicating that you can look at this in very different ways. And of course, in the middle of it is the whole question of a balance between harvest, sinks, and substitution. And how do we account for substitution? A third type of issues was disturbances and the fact that boreal forests are very vulnerable. One question that was posed in the beginning yesterday was, are the boreal forests really performing as well as they have in terms of sink capacity, or is a change ongoing? And then in particular in the discussion this morning, we had a discussion around looking at forest management as cropping systems, and then to compensate for the biodiversity loss, to set aside larger areas for no management at all. Is that one of the options? And finally, time perspectives. How do we look at the next 10, 15, 20 years vis-a-vis these issues? Or should we have a longer term perspective? And I think when we discussed substitution this morning, that was one of the key issues. So, Julia, after this, what are your takeaways?
You raised the big questions, Anders, or the most exciting topics, also in my perspective. So yesterday was very much about this natural carbon side. So it was also about how humans overall manage, but it was not specific about the different options that we have. And so this was all about today. And today, therefore, also went much more into this multidimensionality that yesterday we spoke about, that needs to be considered. And today we were presented with a whole lot of talks that showed these other dimensions, as you mentioned, social acceptability or biodiversity, recreational issues, and so on. And what becomes obvious from all the many interesting talks also today is that trade-offs obviously exist, and they may be large. But this does not mean that there is no net benefit. So of course, by managing heavily, we're reducing some of the other ecosystem services, but it doesn't mean that overall this is a bad thing. It could be, but not necessarily. And so I think we need to just get a better handle on how to make these trade-offs still be optimal in an overall way. Not an easy task, and one that clearly needs much more research, but I think many of the studies showed that we're going in that direction, exactly delivering this research results that we need. We have no time to lose, and we also should focus more, I think, on this interplay of the natural disturbances, the natural carbon sink evolution, and the forest management. There could be a lot of synergistic terms, so that forest management, of course, will also have to adapt to more extreme events hitting the forests and so on. And we've only could touch upon that here in this seminar. So I think this needs more focus. And we spoke also about setting aside areas for these other services that are not just economic, not just focusing on the climatic perspective. But I'm wondering also if we should think more about how to really use the same plot of land and try to optimize across a wide range of functions. So maybe it's not, maybe functions can be combined better than we think, that we know that biodiversity, for example, also increases resilience towards extreme events. So there could be a co-benefit, a nice synergistic term between biodiversity and climatic impacts and also economic value. One question that was raised was by one of the speakers, or one statement was, we need more of everything, and can this be done? And I think this is exactly the point. There's no way back, because we've decided that we want to go for the Paris Agreement. We want to reach very low climate or temperature warming targets. And therefore it has to be done. We need a lot more of this research into these multidimensionalities, into the net effects, into the synergies and trade-offs. And we're going in the right direction, and we need to make it also applicable. And I think therefore this workshop was also brilliant in really bringing together the different stakeholders, not just the scientific realm, which is just part of the solution, but really also make it relevant to those who have actually an impact out in the real world.
Thanks a lot, Julia. Very, very interesting and good remarks. Marco.
Thank you. It's been really exciting 2 days. A lot of science, feelings in there as well, ways of choosing one's words. I'd like to focus on 4 points. The first one is that, yes, it is indeed very clear that we have a challenge of how to manage the limited resource that the forest can provide us with. And there are many ways of using that, of course. But also what is clear from the presentations, etc., is that we are not certain about the size of the challenge, where things like consumption changes or recycling in the future or global markets or innovation, and not only innovation about the biomass, but also innovation on energy sector, efficiency, other materials and so forth. There could also be questions about that. Does the availability of biomass and bioenergy on today's levels in some sense hinder the development of alternatives? We are now in a certain system, it sort of conditions us to do things a certain way. Does that keep us from doing things in some other possible way? One example about the consumption innovation is that the International Energy Agency very recently came up with a report about the pathways. And in their pathways, the energy consumption in 2050 compared to today will be less, even though the population has increased, even though the economy has increased. So energy use would be less, and perhaps also material or virgin material use would be less. Second, about the history that was brought up by a couple of presentations. There's a positive message. History shows that things have changed as in a response to an external driver. Change can be turbulent, but it goes from one state to another one. It can go fairly fast. The Thomas example was about the oil crisis, the Swedish bioenergy system. Of course, the negative message here is that the history has put us here we are today, which means that I think it was said by Sten that we have today's system, but we have new challenges rather than those that brought us to these systems. Third one, often when talking about the forest, one talks about 50 to 100-year time scale, which is the rotation period in the forestry. But 100 years is way too long when we consider the climate challenge, Paris Agreement, climate goals. And it's also way too long when we talk about the biodiversity and social values, reindeer herding in Sweden and so forth. And decisions today sort of, either we will have parts of biodiversity or not, depending on what we do. So we cannot focus only on 100 years and talk about the long time scales, which has been more of a tradition. So we talk about forest management, and really exciting to look at the results on continuous cover forestry, where actually so far one can get a bit confused of what is what and what one should do. But it's about the owners, it's about practitioners, it's about the markets, and about the policy, and at least policy because there's not enough to go around and serve everything, so choices need to be made. Swedish national policy, but also EU policy, which is one determinant, the EU policy, which is shaped together by all the member states. Finally, point 4, just a few thoughts about the way forward on the science side, that indeed, we have many models, we have many results, we have many outcomes. They're not always, often not saying the same thing. So the modeling, the comparisons, standardized experiments, transparency on models, and maybe one challenge that when you get a result, you also try to explain why it's not the same result as other people got. So what are the reasons for discrepancies or differences? Building the models has been set by many consumption alternatives, assumptions about the economic development, disturbances on the natural point of view, valuation of the different benefits from the forest and so forth. That would sort of provide or take us a long way towards having a more overall coherent picture of what we do know and where the uncertainties are. Thank you.
Thank you, Marco. Thank you very much. Now, Christina, may I turn to you? I don't know how much you have been able to attend of the sessions, but I know that you have dealt with these issues for many, many years. So please give us some of your reflections.
Thank you very much. I've been going in and out of the presentations, so I've listened to quite a few, and it's been very interesting. And I think it shows how complex this area is. There is a Swedish proverb saying, "Som man ropar I skogen får man svar." As one shouts in the forest, one gets answers. It maybe not makes any sense translated, but you will get the arguments you want depending on what perspective you take. And depending on what perspective you take and which scientist you ask, sometimes you might get different answers. And we've seen that today. And this makes it really difficult to be a policymaker because we cannot only take one perspective. We have Agenda 2030, we have the Paris Agreement, we have nationally set goals for rural development, for climate, for biodiversity. And the Swedish Parliament has decided on 2 equal goals for the forest. We have production and we have environment, and these 2 should be balanced. And I feel that from the discussions that we have in the Committee of Agriculture and Environment, it has to take in both aspects. There is a strong support for this approach and these goals. But setting goals is quite easy. It's the decisions that need to be taken and the trade-offs connected to it, as Julia was talking about, is much more difficult. But there is one aspect I would like to highlight that is important, I think, when having these discussions. I think it's easy to take a theoretical approach and talk about the forest from like an above level, which is of course needed, but it's important to remember that we are not only talking about trees, we are actually talking about people, human beings. Sweden have 320,000 private forest owners that have different goals with their forest, and each of them have a personal relation to the forest. And we cannot forget about this in the discussions because our decisions as policymakers need to be accepted and understood by the people affected. And it is a challenge to have these many stakeholders, but I think this diversity in ownership and management is also a possibility. But I feel at the moment, many forest owners feel a great uncertainty about which way the forest policy will take, both in Sweden and in EU. And I think that many feel accused in the debate. And this, I think, make it difficult to have a constructive discussion on the future within politics. So I just want to finish by saying how much I appreciate the approach that this seminar has been taking, because I think for us as policymakers to be able to take a system perspective, we really need science to also take a system perspective and help us with the right decisions. Thank you.
Thank you very much. And not least that you bring in the people dimension. Of course, it's very, very important. And if we in this conference have difficulties to really respond to all the questions, it must be even more difficult at the local level. So thank you for that. Now I give the floor to Rebecca Lemoine.
Thanks a lot. And I thank you for these very interesting days. It has been comprehensive, and I especially appreciate the many different perspectives in this issue. But mention from Mike Norton, policymakers and politicians are often left with a feeling of confusion. And I am very humble about the complexity of these topics. And I don't believe in one truth about what is best, because before we can answer what is the best solution, we need to ask ourselves what we want, what is that we value, and what is our goals. And for me, I can't really express this in cubic meters per forest unit or in BNP, Because for me, as a green politician, it is welfare within the planetary boundaries. And one question that came up was today about the assumption about our economy always expanding. And although I know this day is not about this big question, I think it is fundamental. And as Timo mentioned, different values, I find it really interesting that 80%, according to the survey, thinks that production is not the most valuable or important ecosystem service. I am personally still convinced about the importance of protecting the old growth forest and the natural forest with high nature conservation value, both from a climate perspective, nature perspective, and social values. And I am still convinced about the continuous forest management for the same reason, but also I think the local economy can be stimulated by these methods in a better way. And all of it is different results about which forest management model is best for storing greenhouse gases. There is one aspect that is crucial as the climate crisis, which is the biodiversity crisis. And this challenge is huge and it's hard to measure. Some indicators has been used, such as deadwood, aspen, etc. But the truth is that it's much harder to measure the biodiversity than the greenhouse gas emissions. But it's also something that can be quite obvious. If we are looking at a clear cut in Sweden, for example, there's no doubt that this has a huge effect on our fellow species. We have more than 1,800 species in Sweden, which are now red listed due to the clear cutting. And we also have species around the world, but also in Sweden, that is now extincted. So, for example, the black stork or European roller that was declared nationally extinct from Sweden 200 years ago due to the forest management. So my belief is that this situation that we are in now with different crises, we can't just leave it for the market to solve. I think that we as politicians, we need to step up. And in order to create a forestry that is actually contributing to the environmental goals, I think that accelerating the protection rate and financial incentives, laws and transparency is very important steps forward. So thank you, every one of you who have presented interesting presentations and a lot of facts.
Thank you very much. Apropos what you said on can things grow infinitely, I reread an article by Kenneth Boulding the other day. He was a prominent economist in the 1970s and 80s. And I was reminded of his quote that anyone who believes that we can continue growing material use on a finite planet infinitely is either a madman or an economist. And I think that quote is still quite valid. So thank you for your comment there. Jytte, you've played a very important role in the European Parliament context. And I do understand that the role of forest has been very much part of the picture. So please give us your perspective.
Thank you, Anders, and thank you very much for inviting me to this interesting conference. I had the privilege to listen to some of you, not everything, but I agree with everyone in this panel who says this is complex, and we have very different perspectives, yet I'm not very negative. I still see that we have a challenge, but we also have I believe, solutions. So I don't enter the discussion negative. I feel that the rightly done forest management can participate and be part of a solution for a sustainable future. But that said, I would like to start by saying that I agree with everyone who pointed out the big challenge we have for the future, not only when it comes to climate, but also biodiversity. We have a situation with all the political levels need to adapt to and understand that the new society need to be sustainable, and we cannot go on the way we do. And I don't see that there is one solution, but there is a new future that we need to build, and we need different tools, and we need different reforms, and all the political levels needs to do its part. And for me, the climate policy is what I work with most of the time. That is my main work in the parliament, since I'm in the environmental committee and been responsible for the climate law this legislature, but also before I worked with several pieces of sectorial legislation for climate, like ETS is one example, and we will soon also work with the sectorial legislation again. But I would like to say that from the EU level, we have now and in this time we were in a very new debate, and I'm sure all of you is aware and take part of it. And from the scientific view, I believe that you probably contributed to why we are where we are today. But me, who was elected in the European Parliament 2014, I really see that since 2019, there is a political shift and a new momentum for building a more sustainable future. And the European Green Deal is really the big picture. That's the Commission's growth strategy, and the idea is to build a circular economy, and the big flagship is the climate law, and that the goal with the climate law is to reach climate neutrality at the latest 2050. And we recently negotiated the climate law and came to an agreement which is much more ambitious than also the Commission's initial proposal on several aspects, both when it comes to intermediate targets that we made more ambitious, both 2030, but also we introduced a new intermediate target for 2040. We also introduced different tools in this piece of legislation that will also make sure that science is more integrated in the law. And by doing so, I believe that we also connect the climate law better to the Paris Agreement, both by introducing a greenhouse gas budget that will count for that, but also by an advisory panel that will evaluate the climate policy on the EU level. But we also raised the ambition, and there we have a net target to 2030 that will be approximately 57% in both reduction, but also with a coal sink. And that is maybe the most relevant part for this discussion. The intention in the climate law is actually that the forests need to contribute more than before. And I heard from the different panels here today that this is really also long-term objective. It's not so easy to plant trees and just get it working as a coal sink in a couple of years. So it's a more long-term solution. But still, of course, we need to have that part of in the toolbox. That said, I would like to conclude by also speak about forest not only as the coal sink, but also as a tool for this transition that I believe also were pointed out in some of the seminars here today, that the forest can, if it's managed in a sustainable way, also contribute to the transition by introducing more sustainable products, not only be the coal sink and reservoir, but also be actually helping us to substitute the products that is fossil-based today. And I really believe in a balance with nature, with also responsibility to the biodiversity that is also threatened. I really believe that we need also these kind of tools, products that the forest can contribute with. And on the EU level, this is not actually always the idea, because the debate is more about the deforestation and the problem that that is creating for the world. And I would never want to diminish that part of the debate, because it's really important, and it's very true that we have a deforestation that is harming our planet and biodiversity and also climate. But we need to be able to do many things at the same time. And where we have a sustainable management, we can make it more efficient, we can make it more efficient, we can make it also more adapted to helping the biodiversity by having more sensitive tools when we harvest the forest. But we also, I believe, need to use the forest to substitute the fossil fuel materials that we have in our society, not at least when we speak about the big renovation wave that we need in Europe. I really believe that we need wood, and we cannot use plastic the way we do today in the building sector. But all that said, I believe Christina and also Rebecca said things that I don't want to repeat, but that I really agree to, both on the importance of biodiversity that Rebecca did have a very strong speech about, but also Christina on we cannot do this without the people who work with the forest. So it is actually a big balance there that we need to take in concern. And I would like to conclude by saying I know also I'm on the EU level, and some of you might say that the EU has not to do with this. This should be a Swedish thing or a Finnish decision. This is our competence. I would say yes and no. I think, yes, it is lots that is on the national level. But also, if we should tackle the global challenge we have today, we also need to cooperate on climate, biodiversity, and then we will be there a bit on the EU level too. Thank you.
Thank you very much. Thank you, Jutta. And having spent years in Brussels myself, I know that the way people, and in this context, colleagues from different parts of Europe look at forests and forest management differ widely. So that's one of the challenges, of course. Now I turn to Erik Eriksson at the Research Council Pharmas. What are your takeaways? And you may have some fascinating research topics identified.
Thank you very much, Anders, and thank you for the invitation to this very interesting seminar. It's a tough one coming in after Julia, Marco, Christina, Rebecca, and Jutta, but I'll try my best, and all the interesting and excellent scientists that we have heard during these days. Unfortunately, I couldn't be a part of this webinar yesterday, but I have followed the discussion during the whole day, and I believe the 3 sessions here have been very fruitful and most useful. Cooperation and co-creation is the way forward. Boreal forests and climate change are complex, as we have heard from other speakers here, and it relates to many parts of our society. And I could lift several aspects. However, I only have a few minutes, so I will try to lift 3 aspects that relates to what we have heard during the presentation and what have been discussed during the day. First, I would like to stick to innovation. Innovation is crucial, not only to reach the climate goals, but also for the SDGs. And we heard this morning, Professor Thomas Lundmark showed how the forest carbon stock has developed in Sweden during the past 100 years, and how important active forest management has been. But our society have used forest for several hundreds of years, and it's not certain that we will use the forest the same way in the future. Fibers and solid wood could help us reach the climate targets. For instance, it can substitute more energy-intensive materials, but also be used instead of cotton in our clothes, for instance. But innovation could also mean that we have completely new systems in how we're managing the forest, or complete new innovative legislations as well. However, innovation can solely solve the climate change. We have to combine innovation with efficient policies and measures, which we have heard from Jutta, Christina, and Rebecca earlier, and make it certain that innovation don't create new problems to reach the SDGs. My second aspect would be that we need a holistic approach, or a systematic approach. We heard Sten Nilsson and Rolf Björheden, but also others have pointed out that forest is an important part of our society. And as a resource, forests can help us in reaching many of the SDGs, not only climate change. The forest can be used both for, as we have heard here, there is a discussion if it should be used as a substitution primarily, or as a carbon sink. However, we need to consider all aspects of the sustainable development goals and find that balance, and not only look at one goal at a time. An example of a simple systematic approach is that we can probably agree on that we need solid wood and fibers in our society. But by producing wood materials and fibers, we will it would lead to byproducts, and it would certainly be a waste if we didn't use that byproducts in a sustainable manner. And my third and last perspective would be that we need to have both regional, national, and a global perspective. Climate change is a global problem, and countries within the Boreal area can contribute by using the forest in several aspects. And at Formas, the Research Council, we believe that the international dimension is of much importance. We try to participate in as many international cooperation as possible. And by doing that, we believe that we can include many aspects, not only forestry and climate change, but also aspects as markets, consumption, behavior, biodiversity, health, etc. We also heard Jutta recently talking about the EU level, and that we should not stick only to the national level, but I will also like to put forward the regional or the local level. Even if we're discussing the Boreal area today, there is quite a large differences within the area concerning ownership, growth, conflicts with other societal objectives, etc. And that should also be considered. Thank you very much, Anders. I try to stick there.
Thank you, Erik. Thank you very much for those comments. And now I turn to Anders, my colleague at the Academy, Anders Lindroth, who has been following this very closely all the time. What are your reflections?
Well, there are a couple of things, many things, of course, but maybe the one that I was lifting my eyebrows most for was when Philippe CIs presented in the first presentation the weakening of the zinc in the Boreal region in Siberia and Scandinavia, and I think that it's a warning sign that we cannot only look at tree production, because tree production is not equal to carbon sink. And actually, when we look at our data from flux towers, we see the same thing. We have a couple of sites in the Boreal region which have turned from big sinks to sources very recently. And in one of my own study sites, I see the same pattern. It's turning towards a weakening of the zinc. And this is something that we really have to think about. And I'm quite sure that it's an effect of the warming climate, so that respiration is increasing more than photosynthesis, because photosynthesis is also increasing. We know that. So that's one thing that I think we should really consider more. And then actually, I don't remember which presentation it was, but it was someone who concluded that afforestation is not anything for Sweden, but I think it is. And we have forgotten about short rotation forestry. I think it has a great potential because the sink in the short rotation forests are much higher than in traditional forest, and it goes much faster. So we can really do something in a very short time perspective, 10 years, and we can do a lot. And there is a lot of land possible to use for this. It was an official investigation. I don't remember which. Wasn't we involved, Anders, both you and me in that one? We wrote a review on it for the Royal Academy of Science. There it was also described that there were areas available for this. We haven't talked about this during these days, but it's something I think we should consider and think about. And this is something that could be for the whole of Europe, not only for Sweden and Finland. Another thing I think is, I don't like this complete focus on a fossil-free country. I mean, the most important thing is what happens in the atmosphere. We should really assess all measures that we are doing, how we are using the forest, how we are using anything, how it will affect the concentration in the atmosphere, because that is what is important during the next coming 10, 20, 30 years. And it might be so that we continue to use fossil for a short period of time if it can help us to keep the levels of CO2 lower in the atmosphere. My example goes back to what we've seen on a global level. I mean, who can say that the forest has been damaged by the fossil fuel emissions so far? I don't see that. We store it. We store the same molecules in the soil and in the trees. I find it quite surprising that we have focused so much on this mantra fossil free, because it might lead us the wrong way. It's most important to reduce emissions to the atmosphere, and we need a system to assess that. Another thing final thing I would say is that I was intrigued by Timo's presentation and his definition of continuous cover forestry, which I have completely, I haven't realized that it's so simple. We don't have to turn it into an uneven age forest system, which take 50, 100 years. We can just stop doing clear cutting. So that was a big eye opener for me. So I think that is something that also the private landowners would be very, very interested in hearing and seeing what they can do. I think it's much easier on a small owner level than for the big companies, because it's difficult for them to change all their methods and so on. So that's my comments. Thank you.
Thanks a lot, Anders. Building on that, I think one of the knowledge gaps, or at least to me, where we need more research, would be to understand better the difference between continuous cover forestry and rotation forestry. Timo gave one presentation, Rolf a different one. There were commonalities, but there were also huge differences. So I believe we need to understand this better. And the whole issue of resilience has been touched upon at several occasions. Maybe Juliana was the one who, towards the end of her intervention, said, maybe the best thing is to have parallel existing management systems. That is probably the most resilient system. Another issue where we obviously need more knowledge is about nature-based solutions. We talked a lot about them yesterday, but don't forget that that was part of the objective of this webinar, to really focus on nature-based solutions and the role they can play. I think what is obvious also is to understand better how forest management practices can, on the one hand, reduce vulnerability to disturbances, and on the other hand, help strengthen the carbon sink in the short term, but also in the long term. And then I think one thing that in particular Sten Nielsen alluded to was that today's models are not perfect. There are things that are lacking from the models, like nutrition, like humidity, etc. So there is another area where I think research and the research community has a lot to contribute to. Well, we are moving towards the end of this two-day webinar. Marco, Julia, you've heard the comments in particular from our policymakers. Is there anything you would like to add?
I'd be happy to pick up on one aspect that was mentioned several times, but in particular Eriksson brought it up. It was fabulous what we learned about the boreal forest now in these last 2 days. But we need to take this perspective more globally. So a lot of what we're discussing here probably can't be discussed just from this perspective of what you demand will bring about, how we can possibly compensate different types of products in the agricultural sector, but also in the industrial sector, without considering what the rest of the world does and what our choices do to the rest of the world. We know that we're trading about 1/4 of the fossil fuel emissions, and numbers seem to be similar for land use emissions. For example, we're importing in Europe a lot from Brazil and other parts of the country, other parts of the world, in terms of agricultural and forestry products. We're also exporting a lot, but there's a big trading system behind it. And sometimes it's not optimal. So sometimes our consumption here leads to really moving into pristine rainforest elsewhere in the world, where the carbon loss per unit calorie, for example, that you're producing is much higher than if we produce the same thing here. Or where the damage is potentially also quite high. It's a different type of ecosystem, and I can't judge which ecosystem is more valuable because it has so many different aspects to it. But we should also always consider how local or national choices may play out in the global system. This includes the global market. This includes also global normative values. And so maybe the next seminar that we could organize should put this into the global perspective.
Thank you, Julia. Marco?
Well, I appreciate it very much. And I also agree that there's a window of opportunity for policy on the union level, not least, but it has also national connotations, of course. The ongoing processes around revisiting LULUCF and RED, and the forest strategy and the biodiversity strategy. And I would imagine that the new climate goals will also lead to discussing again the ESR and emission reduction and so forth, how these are distributed between the countries, the union. So there's a climate policy window of opportunity, but I guess where things can be sort of spun up so that we meet the challenges over the short time period that we have at the disposal. But I guess the challenge is to try to sort of make this into a package so that they pull in the same direction, they support each other, they don't overlap each other, there are no gaps left between the different directives and well, all these things. So I understand that these are complex issues and you're working hard on these in Brussels and the national level. I just want to emphasize that this is very important to have this as a package, pulling it in the direction that we want to go. Thank you.
And if I may add, in particular to Jytte, I think it's very important to understand better what substitution really is all about and how we can move from maybe 80% of substitution today, taking the role of short-term, short-lived products and moving more towards long-lived products. And that's not only construction in wood, that could be a lot of other activities as well. And there, of course, innovation comes in as a very important issue. Well, dear friends, I think we should conclude. Thank you very much for having this patience, staying on for all the day, and most of you also yesterday. We value your comments. We thank you for your inspiring comments, I would say. And I was very happy that the last panel, you looked at opportunities, which I think is the only way forward. There are indeed opportunities. So with those words, Lars, I hand over to you.
Thank you. Well, thanks to everybody in this very lively last panel discussion, of course. But thanks also to all the speakers today and yesterday. And also all the people that have helped us behind the scenes. So from Future Earth Stockholm, where Wendy Broadgate and Naomi Lubeck. Also Erik Pihl on and off stage, as you know. And we have Camilla Grunditz. And especially Peter Brandén at the Academy, who has masterly been directing the technology that has made this meeting possible. So thanks to everybody and goodbye. And probably we'll meet sometime in not too far away time, because this is a topic and a set of questions that really need to be seriously discussed. And I think this meeting has been enormously productive. So thank you very much. Bye.